Hi everyone and welcome back to PrepFusion. So today we'll start the new chapter of engineering mathematics, that is complex analysis. So again, right, this will be a very interesting chapter and this will be a bit lengthy, just like you can say vector calculus. Obviously differential calculus and like normal calculus chapter and our linear algebra, both of them were very big, but it won't be big as those, but it will be big like vector calculus. It will also have, first I will teach you the basics of complex numbers, like basics of complex variables that we have already studied in 11th and 12th. But if for some reason you haven't studied well or you have forgotten everything, right, you can watch the lecture. So what should you do? Like if you have already basic knowledge about complex numbers, what you can do, you can try to solve the quotients in this lecture. You can go to the PDF and solve the quotients. If you are able to solve the quotients, that means you remember the concepts. Okay, then you just need to quickly go through the notes and that's it. If you aren't able to solve the question, if the question seems difficult to you, then obviously you need to watch lectures, because you have to have the concept of complex numbers, good concept of complex numbers, then only we will be able to proceed on complex variables. So GATE asks some basic questions on complex numbers as well. They don't skip this, right? So they sometimes ask from here as well. So you have to be thorough with complex number as well. So that's why it is important, and I told who to watch and who can just go through the notes. Okay, I told that thing. And also this is only for computer science, and for every other branches you can check your syllabus, right? Obviously they can change syllabus, but for now what syllabus I have seen, that except for CS and CE, it is for all other branches: mechanical, instrumentation, electrical, EC, and chemical, all the other branches it is there. But for civil and computer science, this chapter is not present, so you can lie and take a sigh of relief that this chapter isn't there, right? So you can study something else. So let's start with the lecture 0. So in this lecture we'll study the basics of complex number, which we have already studied in 11th and 12th. So first of all, I will give you a brief overview what we have finished till now. So I will just give you a brief overview of complex calculus, right? So in calculus, basically mainly calculus has three parts that we have studied. That we had three types of functions, right? One was real function, okay, which we started at the first second chapter, that is of engineering mathematics. Then we finished vector calculus, which had vector function. Vector functions are defined like this, which has also direction associated with it, right? Then we studied complex functions. So we will study complex functions. So complex function, what is complex function? Complex function is anything which has complex variable involved in it. So what is complex variable? We'll just study in the next few slides. And this you already know, right? What is vector variable, how to define like a position vector, and what is this, right? This is, we first of all started with real variables, then we shifted to vector variables, then now we'll shift to complex variables. And in real functions we studied differentiation, integration, then we studied differentiation, integration of vector functions. Now we'll also study differentiation and integration of complex functions. So basically GATE wants to know all these things, right, for different types of functions. GATE want you to know this. So now, what is complex numbers? A complex number is the sum of a real number and a imaginary number. Like the example is this, right? This is a complex number, 4 plus 3i. 4 plus 3i is a complex number. Now, you might say, sir, still I couldn't get the feeling, right? What is complex number? The main thing is, real numbers we already know. Real numbers which can be defined in nature. Okay, so let's say I have one apple. You can show that you have only one quantity of apple. I have 1.5 apple. That means you have one apple and half of the other apple, right? But can you say I have 3i of apple? 3i. What does 3i mean? Like, I hope you have studied, you know already the definition of complex number. That is this, right? Iota. It is under root of -1. Now, you can't say 3i of apple, right? Because we can't represent it in nature, in real life. So what is the problem over here? The problem is that one problem came that we had to define this number, right? Because this number wasn't lying in our number line under root of -1. Because under root of negative numbers, we weren't able to represent those, right? We weren't able to represent under root of -1. So for that, we had to choose a different variable itself, which is complex number, because complex numbers are very important. Why? Because we can do mathematical operations, which we couldn't do if these didn't exist. Just take an example of phasor diagram, okay, and any other thing, right? We use complex numbers in our electrical engineering as well, solving AC circuits and all those things. We take help of complex numbers while doing the frequency response. We replace S with j omega. So obviously we take help of complex numbers. Complex numbers are nothing, just a mathematical tool for engineers, like I'm specifically talking about engineers here, for engineers to do our mathematical operations, right, or do our engineering calculations. That's why we have complex number is very important for us. So I told you what is complex number, why is complex number important. Now what is like this 4 plus 3i is a complex number, as this is a constant, right? 4 is a real number, 3 is a real number. Now what is a complex variable? When it changes to variable, basically. So when it varies, when the real part can also vary x and the imaginary part also varies y. So in generally a complex variable are defined like this: z equals to x plus iy, and x is variable and y is also variable. Okay, so we can also represent our complex number like this in a form of ordered pair. Okay, in a form of ordered pair, you can also represent it like this. Okay, so there is a few written like definition you can read. A complex variable is the form of this and usually represented by z. Both x and y are real numbers, so you have to understand here that our x and y both are real, right? They are not complex, but this, due to this I, this becomes a complex variable, but this x and y individually has to be real. If this y also becomes complex, then some real part will come, right? If it becomes imaginary number, and that I forgot to mention, that's why we call it imaginary number, because we can't like show it, right? I can't show you I have 1 iota of apple. Can I show it? No, it's like imaginary thing. You just imagine everything just to perform mathematical task on paper. We can't show it. That's the main thing. So these, right, x and y are real. Okay, x and y are real. So this is the case. Like you can read where I've told you, like x is called a real part of real part of the complex variable, and it is denoted like real of z, and y is called the imaginary part, which is denoted by imaginary of z. Like these are notations, you have to like remember this. And y is also called an imaginary number, right? Y is called the imaginary part, and iy is also an imaginary number, because y itself is real, and I times any real number makes it purely imaginary. Now there are few properties of iota. I will blaze through them because I hope you know all this. If you don't, like let's just like you can take few examples and there you can solve, right? So if my iota is -1, okay, it is under root of -1, that is -1 raised to power half. If I do I square, what will I get? If I do I square here, -1 raised to power 1/2 square is -1. Now if I do again multiply I on both sides, okay, right, on the left hand side it will be I cube, and on the right hand side it will be minus of I. Okay, now if I multiply I on both sides again, it will be I raised to power 4, and in the right side it will be minus I square. And what was I square? I square was -1, and minus sign is already there, over there, it will be 1. And after that, right, what will happen? It will just follow a cycle, it will just follow a loop. Again if I multiply I, okay, this will be I raised to power 5, and this will be I, which I'm at this first stage, right? Then again if I multiply I, this will be I raised to power 6, and this will be I square. And what is I square? -1. So I'm just revolving. So basically this plane, right, this is also called a R-gram plane, which we'll learn in the next few slides. So if I keep on multiplying, I'm just rotating in a circle. So first I was at this point, right? I was at this point, okay, then I multiplied I with it. Okay, if I multiply I with it, I will move to here. Just if I multiply I with it, then again if I multiply I, I'm just moving in the anti-clockwise direction, right? Again if I multiply I will move to here. Okay, this is not up to scale, so please forgive me. Again if I multiply I'll move here, it will be -1 I square, that means -1. Again if I multiply I, what I will get? So this will be minus of I. Again if I multiply I again come back to the same place, that is +1. So now again if I multiply I will again follow this same loop again, right? So that is exactly what is happening over here. I'm just going through a loop, and like that is what is written. So my k is any integer, right? K can be any integer. Okay, so I raised to power 4 is what? 1. So you can verify here, k can be any integer. 4 times if it is a multiple of 4, any integer that is multiple of 4, if I raise it to the power of I will always get 1. I raised to power 4, I raised to power 8, I raised to power 12, you see. Okay, then I raised to power, now if it is a multiple of 4k plus 1, okay, it is like 1 I raised to power 1, I raised to power 5, I raised to power 9, like this, then it will be always I, and so on. Like you can see the properties, and this is the most important property. You have to like this, you don't have to remember, this will automatically get installed in your head, right? So if I add up all the numbers, okay, of 4, right, between 4 powers. So basically first I'm adding I raised to power 1, then I square, then I cube, then I raised to power 4. What is happening? I raised to power 1 is I itself, I square is -1, I cube is -I, so I minus I gets cancelled, I square is -1, and I raised to power 4 is 1, so -1 gets cancelled. So overall what do I get? I get 0. So for this is for any 4 summation of my iota which are like in sequence, right? In sequence, they are in sequence, or which differ by 1 power, right? So let's say I square, I cube, I raised to power 4, I raised to power 5. You do that, you will see that everything is getting cancelled. Okay, if it is in a sequence of 4, okay, you start from any power, right? K can start from any power, but they should be in sequence of 4. That is the most important part, and the overall answer will be 0. So these type of question can also come, but if you are anywhere you get confused, right, you can directly convert this, right? I can directly convert this. Okay, so like you know these conversions, right? If you are not able to remember this, you can directly convert this to these basic things, right? Like I -1 plus I and minus plus 1. So these 4 things you can convert, and then you can solve if you are not comfortable while remembering this. But this does help in solving the questions in a fast manner. So we'll solve one question. Okay, so what is the value of this sum? N is going from 1 to 13, where I is minus of under root of -1. Okay, what is the value of this? So like, but I told you it is for sequence of 4, right? Here I've only got sequence of 2, and it is going from 1 to 13. So whenever you get these type of problems, right, these summation types of problem, first let's break it down. First of all, my n is a variable. Okay, can I take something common over here? Can I take anything common from here? I can take I raised to power n common from this, right? Because this is I raised to power n, and this is simply written I raised to power n plus into I. So what I can do is I can take few things common. So whenever you see summation, right, and whenever you're feeling overwhelmed, just try to simplify it, and then you try to observe some pattern. So okay, so this will be I raised to power, and I can take common, this will be 1 plus I. Now here, right, n is variable, and this I plus 1 is constant, so I can take this outside of the summation because this is anyways constant. Only I raised to power n is my variable which is varying with respect to n. So what I can do, I can take my I plus 1 or 1 plus I outside the summation because it is just a constant. It will be multiplied with everything. This will be I raised to power n, and n is going from 1 to 13. Now let's write few terms, right? Let's write few terms. If I write few terms, it is starting from 1, so it is I raised to power 1 plus I square, then I cube. Okay, so I am observing it is following a pattern. Okay, it is following a pattern that it is going up until I raised to power 4, but here it is ending, right? I raised to power 13, it is ending. So what will the answer? Will the answer be 0? Will the answer be 0? It won't be 0, right? Why? Because what is happening? It starts from I raised to power 1 to goes to I raised to power 4. That overall answer is 0. Then it starts from I raised to power 5, it goes to I raised to power 8. Okay, so again the whole answer will be 0. Then again it will start from I raised to power 9, and it will go to I raised to power 12. Then again the whole answer will be 0 because it is a sequence of 4 powers of I. Okay, sequence of 4 powers of I. But at the end I will have I raised to power 13 isolated. It will be remained as it is. So I will be remain with I raised to power 13 only, and all others will be 0. So this, right, this can get converted. I can convert this. This will be 1 plus I into I raised to power 13. Now can you simplify this? Again, for simplifying iota power, right, you always divide the power by 4 and you see what remainder I have. So here I have, if I divide this by 4, what will happen? Like, or what you can do, you can write it like this, right? Like if you want to divide it by 4, what you will say? 13 divided by 4 is equals to 3 plus 1 by 4, right? 3 plus 1 by 4. So, or how you can write? You can write it like this, right? Like this will be 3 Oh no, this will be, yeah, this will be 3. Now this is raised to power 12. I have one more extra I present, so I will write that extra I here, right? So just to give you an idea, right, 3 will come over here. Okay, 3 will come over here, and that extra I will be here only. Okay, so that's how you do, right? That's how you do the mental calculation. You just try to find the multiple of 4 in the power, and you divide that, right? 3 will be the multiple of 4, and whatever remaining is there, I write it as it is, right? So I is as it is. So I want to convert it into our base terms: I minus 1 plus 1 and minus I. So this I raised to power 4 is what? This I raised to power 4 is simply 1. So obviously we replace this is 1 cube is anything, I don't care. So that's why we replace it to the I raised to power 4. So we don't care about it. So only I am left with I. So this I is multiplied here and here. So it will be what? It will be I plus I square. So I is, it's there is an I square is minus 1. So it will be minus of 1. So I minus 1 will be my answer. So option B will be my answer. Okay. Option B will be my answer for this question. So like this is relatively easier. If you aren't able to solve, obviously you have to practice few more questions, right? Just hold on a second. I will drink a bit of water. Okay, so let's come to next question. So Gate has asked this question. Like this is much simple. So roots of the algebraic equation x cube plus x square plus x plus 1. So what are the roots? Roots means which satisfy the equation. So basically what you can do, you can put the values over here like that, you can do. Or what I'm observing, this is a sequence of 4 powers, right? I raised to power 0, I raised to power 1, I square, I cube. So I will obviously be a root of this. Where is I? Or like they have represented J as a complex number. In electrical engineering, sometimes we represent J as a complex number, but in all other branches, we represent I as a complex number. Just be careful about that. So yeah, J is over here. J is not here. J is not here. So obviously it isn't possible, right? These options are not possible. Okay. And J is also over here. Now here we have minus 1 and plus 1. Obviously you put the values and then you see which one is satisfying. So this is a differentiating factor. Minus J is also here. So only I have to put minus 1. If I put plus 1, right? If I put plus 1, it will never satisfy because plus 1 is simply 4. So obviously my answer will be minus 1. You can put this value over here and you can check, right? Minus 1 cube is minus 1. Plus 1 cancels out, then minus 1 plus 1 cancels out. So it is satisfying. So it is 0. Now you can put minus J as well and you will see it is also satisfying. Okay. So yeah, these are basically pretty simple questions and you will be able to solve this flawlessly. So now come to operations of complex number, which we already know, but just for the sake of it, I have to teach all this, right? So what are operations of complex number? If I have two complex numbers, okay, or you can say complex variables. So if the two complex numbers are equal, if it is given that the two complex number is equal, that is z1 equals to z2, then the real part of those complex number has to be equal and the imaginary part also has to be equal. So they have to satisfy these two conditions no matter what, right? So you will get two conditions in one equality. Okay, so you will get two equations in one complex number equality, not inequality, so one complex number equality. So real part has to be equal and imaginary part has to be equal separately. Now if I add two complex number, the real parts will get added or subtracted, or the imaginary parts will get added or subtracted separately. Okay, simple thing. Now multiplication, right? If I multiply two complex number, you can multiply, you can see, right? We can break it down in terms of bracket and you can see. So what will happen? Multiplication of two purely imaginary numbers will give you a real number. So this I, y1, y2 will be here. This will also be real number, and multiplication of two real numbers will anyways give you real number, but multiplication of one real number and purely imaginary number will yield you a imaginary number itself. So these, right, these combinations are here. Okay, these combinations are here. So that is the case. Now what is important? Important fact is, we learn soon the Euler's representation. I hope most of you guys know. If you don't know, we learn this. So you don't use multiplication like this, right? Whenever you have to do multiplication, like you have to be smart, obviously. You have to understand when to use this and when to use the Euler's representation. Through solving questions, you will understand. But most cases, right, we'll use Euler's representation for multiplication of numbers and not this simple a plus b into a minus b, not like this, right? We will not use this. Same for division as well. That we'll use Euler's representation for division. Okay, you can, like, what are you doing here? Okay, we want to convert this into simple terms, right? We want to separate this in simple imaginary and real terms. But here, right, this is not like that. So what I do, I just cross multiply with x2 minus iy2 to to make the denominator purely real, and here, right, again multiplication of two complex number, if I apply, then I can separate out the real part and the imaginary part. But this is messy. What we will use? We will use the Euler's representation, which we will learn later on. Okay. Now another operation is there, that is conjugate of complex number. So what is a conjugate of complex number? So let's say I have a z complex number 2 plus 3i. So if I want to find the conjugate of it, what will be it? It will be simply, I will just make the imaginary part negative of what it was previously. So if my previous, like real part, I will not touch my real part will remain same. What will happen? I will just make the real imaginary part opposite. It will be minus 3i. Okay, so it was plus I previously, it will be minus 3i. Basically it creates a mirror image along the z plane, which you will understand, right? So just you try to, you know all this, I know. So the conjugate of a number is simply just making the imaginary part opposite of what it was previously. Okay, so let's solve one question, right, on basically operations of complex number. These type of question also comes. Okay, so you have been given z. Okay, then what will be z raised to power 4? So, and obviously you won't multiply z 14 times, right? You don't do that. You won't do that. So obviously what will happen from the option itself, I am observing that if I simplify this, something simple I will get, right? If I just rationalize this and keep the imaginary real part separately from the options itself, I am taking the hint. So obviously I won't multiply z 14 times. What I'll do, I will first simplify this and then I will see what pattern I am getting. So how to simplify? I've told you, right? If two fractions are there, obviously we can use Euler's representation, but as we haven't learned that, we will use normal method only, multiplication and division of complex numbers. So first what I will try to do, I will try to make the new denominator real. So basically what I have to do, z is equals to 7 3 minus 4i and this will be what? This will be 3 plus 4i and 3 minus 4i. This will be 3 square minus 4i square. Okay, so it will be 21. So I'm just multiplying the top one for now. So this real times real is real, and purely imaginary times purely imaginary will also be real. So I times 4i minus 4i, it will be minus 4i square. So minus 1 into minus 1 is plus 1. So 4 plus 4i. This will be not 4i plus 4. And here I will be there. Now this I times 3 is 3i. So 3 will be here. And 7 times minus 4 is minus 28. Okay, I will just change the color. This will be 9 minus 4i whole square. Okay, like this will be 3 square minus 4i whole. This will be 25 basically. This will be 25, and here, right, on the top also I can take common 25. So it will be 1 plus 1, not 1 plus I, 1 minus I divided by 25. This, right, you can simplify with Euler's also, like taking the power, which we'll learn later. But for now, let's just understand this. So 25 is this. This is 1 minus I. Again, right, if I want to raise this to the power of 14, which will be difficult for me. Okay, if I keep on multiplying. But let's see, right, if I multiply it twice, any pattern I am observing, then again thrice, any pattern am I able to observe. So I will try to multiply it with itself again. So what is 1 plus 1 minus I whole square? It is 1 square plus I square minus 2i. So 1 square is 1, I square is minus 1. So this gets cancelled and I am only left with minus 2i. So now it is simple, right? They have told me to find z raised to power 14, but this is equals to z square, right? So what will be z raised to power 14? If I raise this to the power of 7 on both sides, I will get z raised to power 14. So this is more simple, right? Instead of a plus b, I am getting a single term only. That's why. So now I am raising this to the power of 14, not 14, 7 to get 14 itself. So this will be minus 2 raised to power 7. So minus 2 I can keep, right? Minus 2 raised to power 7 I can keep. Anyways, it will be odd, so minus I can take outside. Okay, it will be odd, minus I can take outside. And just hold on. Yeah, minus I can take outside because it's odd, right? So what I am talking about? So I am talking about this, right? So I have minus 1 raised to power in times 2 into I raised to power 7. So minus 1 raised to power any odd, right? Any odd number will be minus 1 always. Minus 1 square is 1, minus 1 cube is minus 1. So it will be always minus 1 will come outside. Then 2 will be alone, 2 raised to power 7, and I raised to power 7 will also be alone. Again, right, I will break this down in terms of multiples of 4. So what is this? This is simply minus 1 minus 2 raised to power 7 into I raised to power 4 into I cube. What is I cube? I cube is minus I. Okay. So I cube is minus I. So this becomes plus, right? Overall this becomes plus. So 2 raised to power 7 into I itself. So this will be my answer, because here I have minus and this I cube is minus I. Minus minus gets cancelled and I am only left with I. So overall my answer will be 2 raised to power 7 into I. Okay. So you have to be careful, right? You have to be careful with all this. So they can play with options as well. So you have to be careful with all this. Okay. So this time, right, my answer will be C. Like there is not much to explain. Like this is 11 standard problems. This you should be able to understand, right? So now let's start with the representation of complex variables. This is not variations, variables. So how do you represent? First of all, I told you, right, at the starting of the lecture itself, we had the real number line which represented all the real numbers. Okay, 0, 1, half, rational, irrational, everything was inside this number line for representing the real numbers. But how do I represent complex numbers? So I create another number line which is called as an imaginary number line, which is just like the real number line, except, right, I have iota, except I have just iota present with it, so it makes it imaginary number, purely imaginary. So I have another number line which is known as the imaginary number line. Next, what I do? Next, I make a plane with it, because this becomes two-dimensional, right? Initially, I had only 1D because I had only the real number line. Now I have 2D. This becomes a plane because I have an imaginary number line as well as a real number line. So, real number line is on the x-axis and the imaginary number line is on the y-axis. And this is known as the rectangular representation, or also known as the Argand plane. Okay, also known as the Argand plane, also sometimes known as the complex plane. Okay, these are just the names. Don't have to stress that much. Okay, it's a simple xy axis, but y this time represents something. Y represents the imaginary number line and x represents the real number line. Basically, it is the real part of z. Here, the notation I can, like, you can observe real part of z, and this is the imaginary part of the z with I multiplied with it. Okay, so this is complex plane. Okay, don't worry about the names, these are just the names, nothing else. You don't have to stress anything. So how do I represent? Like this is known as the Cartesian format also. All these things you know, right? Like Cartesian is always in x, y, and polar will be always like in some other plane. I will talk about polar later on. So if you want to represent a number in this Argand plane, how can you represent a number? So let's say I want to represent 3 plus 4i. I want to represent 3 plus 4i. So if I want to represent 3 plus 4i, what will be the real of z? The real of z will be 3. And the imaginary of z will be 4. Okay, the real of z will be 3 and the imaginary of z will be 4. So what is this? This is the x coordinate and this is the y coordinate. So x coordinate is here, so I will move 3 steps along x direction. Okay, 1 2 3. Then I will move 4 steps along the y direction. 1 2 3 4. Okay, so I will lie somewhere around here. So I will lie somewhere around here. Okay, and this point is basically 3 comma 4. Like it can be represented like this, or this is p can be equals to 3 plus 4i also as well, right? So yeah, this is how we represent this, right? Sometimes we write this as x. I'm just talking about representation. These are not that important because you solve questions and you will understand, like this is automatically understood by you. This also sometimes is written as iy, and this is how we represent a point in the rectangular Argand plane, right? Rectangular plane or Argand plane, whichever you want to name, you can name that. This is 3 comma 0 and this is 0, 4. Okay, so this is the case. So like this is how you represent in the Cartesian format. Now how do we represent in the polar complex plane, right? So this polar representation, this also sometimes we call it as polar complex plane. Polar complex plane. Okay, so like how do you represent? Nothing, right? Just simple thing is it is r and theta, right? So polar complex plane is basically r and theta. So I approximate a circle and find the distance from the origin where that point lies. So this, right, what is the distance from the origin if this point lies? So if I draw this will be like a right angle triangle. Okay, and with the help of Pythagoras theorem, the square of this and the square of this, then if I take the under root of this, then this distance I can compute, right? So I found out the distance and how much angle I have to move from the positive x-axis. That will be the value of theta, and that is basically what is meant by polar representation. The distance from the origin and how much angle I have to move. Basically I will take a pointer, and then I will just move around. I know the pointer, I know the magnitude of the pointer, like the magnitude length of the pointer. That is, what is it? It is 5, right? Pythagoras theorem, 3 square plus 4 square under root is 5. So I know the magnitude of pointer, which is 5 units. So this will be 5 units, or I can say r distance, right? And then I can also say how much angle I have to move from the positive x-axis to reach to that point, right? Exactly to that point. So this will be my same P point which was in the rectangular, which I can say here. So what is like r here? The distance is 5, right? Distance 5. Distance will always be positive. It can never be negative. Okay, but theta can be negative. I will explain about all those things. And what is theta? So like this is again, right? This is again a right angle triangle. So what is theta? Theta is basically, if I apply the what? If I apply the sine rule, it will be sine theta will be opposite upon hypotenuse. Opposite, the distance of opposite reverse is what? 4. 4 upon hypotenuse, 4 upon 5. So sine theta is 4 upon 5. What is theta? Theta is 53.13. This number you have to remember, right? 53.13, 37. Was it 53.13? 37 from 0.86, something like that, right? If I remember correctly. So this will be 53.13, and obviously you have to convert it into radians. So generally we write here in terms of radians. So 53.13, so like pi is 180. So 180 by pi will be pi by 180 will be 1 degree, and pi by 180 into 53.13 will be 53.13 degree in radians. So this will be, always use the unitary method, pi by 180 into 53.13. This will be my r and theta. So this, like this is represented like I will explain here. It is represented like r and theta, right? P is represented like r and theta. Okay, and r and theta in this case is this. Okay, or there is some simpler way to compute this angle, which I will talk about, right? Instead of going to sine, we can use the tan as well. Okay, so we don't have to compute the hypotenuse. That's why we use the tan, because these two sides we already know. We know what is x, we know what is y. Okay, so we can simply compute. It is tan inverse y upon x, which is 4 upon 3. So you can compute like that. Okay, so this, right, how can we represent it in polar format? How we represent is this, that it is represented like this. It becomes mod of z. Mod of z is basically the modulus of z, which represents the distance from the origin, and cos theta plus I sin theta. So we observe this, right? This is the modulus of z, which is basically the distance, right, from the origin, which is basically the hypotenuse of this triangle. If I do this, right, this is mod of z. If I do z cos theta, what will I get? I will get the x coordinate, which is exactly written over here, right? Which is exactly meaning the same thing. Again, if I do z mod of z sin theta, which will be my y coordinate, which is present with the imaginary term, which is exactly also same over here. So we're just converting the representation, nothing else, right? This is just representation. So obviously I can write here my x will be r cos theta, y will be r sin theta. Okay, x will be r cos theta, y will be r sin theta. And now if I just replace my x with r cos theta and y with r sin theta in the Cartesian form, my z will become r, I can take common, cos theta plus I sin theta. So basically my R is what? R is this mod of z. So my, okay, if I have enough space, R is equals to the distance. So I will write mod of z because that is the more important term. Mod of z is the distance from the origin. It is simply x square plus y square, which is equals to r. Okay, is simply x square plus y square, which is equals to r. And angle of z is what? Angle of z is what? Angle of z also known as the argument of z. Okay, angle of z means this theta, right? Theta basically. So it is also known as the argument of z, or theta also it is represented, r theta, which is equal to tan inverse y upon x. But there is some condition, right? There is some condition with it. This is not always the case. Not always. Okay, so for polar representation, these are the few things that you have to remember. So these, right, you can put in short notes or something, or like you don't even need to put in short notes because this is self-explanatory. So these things are very, very important. Okay, for polar representation. Yeah, these are the basically things. So theta, right? Our theta can vary how much? So our theta, I will say here itself. So theta can vary from minus pi to plus pi, and my r will always be greater than 0. It cannot be equal to 0, like it cannot be less than 0. It cannot be negative number. And here, right, my x and y can go from minus infinity to infinity. All of them are real, right? They have no boundations with them. Okay, they can go from minus infinity to infinity, because basically the z plane. So these are the few things that these you need to understand. So like here, right? So let's come to like the definition of this. So modulus. Modulus is the distance of the complex number from the origin as represented in the point in the x iy plane is called the modulus of complex number. This I've already taught you, right? It is simply x square plus y square. Basically the Pythagoras theorem we are applying. Now argument. Argument is the angle made by the line joining the geometric representation of the complex number and its origin. So how much angle I have to move from the positive x-axis, that is what argument is, right? Now the thing is, look, it is a definition, right? It is a definition. So we have to define by ourselves. We have to set the rules by ourselves how we want to define the argument. Because what is the problem? You might say, sir, the argument is 53.13 degrees. I might say, if I just rotate it once here and then again do this, so it will be 53.13 degrees plus 360. So again, I'm reaching the same point itself. Again, if I rotate, it will be 720 plus 53.13 degrees. Okay, that can also be my argument, but we have to set boundaries, right? So we talk about principal argument. So this, right, our principal argument, that is once only rotation. Okay, we don't rotate again and again, because if we rotate a pure circle, it is the same place. We get back to the same place itself. So our principal argument, this is the principal argument, should lie between minus pi to pi. Okay, so I will not write it over here. Like theta can go anywhere, right? Theta can vary anywhere. R has this 0 to infinity. But principal argument, right? Principal means only once I am rotating. So that should be from minus pi to pi. So what does minus represent? I am talking about positive x-axis. I am rotating about the positive x-axis. So about the along, if I rotate along the anti-clockwise direction, we assume anti-clockwise as positive. I have told this many times. I think why you assume this. So if I am rotating along the anti-clockwise direction, it is positive. So it will be positive. If I rotate along the clockwise direction, so from the positive x-axis I am going downwards, so it is negative, right? That's why. Now, is this covering the total circle? Yes, this is. So this is covering, like if I am going from this 0 to pi, this is covering the upper semicircle, and if I am going from 0 to minus pi, this is covering the lower semicircle. Now you might ask, sir, why don't you use 0 to 2 pi? Like that's more better, right? It is positive. Like first thing is they have set the rules. Second thing is it's easier, right? Instead of writing 0 to 2 pi is a large number. So what you do, we can travel halfway, so it becomes 0 to pi, and in the other half we can travel in the negative half, right? instead of traveling along all this, right, I can simply take this shortcut over here. That's why it's negative. This is just my theory, nothing else, right? They have set the rules, and you have to go according to the rules. You can argue with me, okay? So principal argument should always lie between minus pi to pi, and how to compute the argument. How to compute it, that's very important, right? I've told about coordinate systems, this computation of angle many times. Still I'm explaining you here also once. So how to compute? So first of all, you have to find theta. What is theta? Theta is not the argument of z. Theta is not the argument of z. That's the first important point. So this is my notation, so you have to follow my notation only. You can't follow any other person's notation. So theta is not equals to argument of z. This is the first misconception. You have to clear this, right? Theta is not equal to argument of z. Theta is some variable. What is theta? Theta is tan inverse modulus of y divided by modulus of x. So what is it? Basically, I'm only taking the positive part of y and positive part of x. Why? Because if I'm lying on the first quadrant, then my x and y are positive, then this theta doesn't change, right? Theta, like this modulus of y and x doesn't change anything. But if I'm lying in this second quadrant, what happens? My x value becomes negative, okay? And it causes a problem, which we will understand. So here, if I just simply use the Pythagoras, or not Pythagoras theorem, basically use the trigonometry, right? If I use the trigonometry, I will be able to compute this angle and not this angle, but I want to compute the angle with respect to positive x-axis. So what do? I simply first compute this angle, okay? Then this overall angle is 180 degrees. If I subtract this angle, right, I will get back this angle itself, right, which is the angle that I want, So I just need to subtract this angle, and exactly that is written over in gradients. Pi means 180. So pi minus theta is this angle, because here, right, sides can never be negative, right? The sides of a triangle can never be negative. So I'm computing the angle for the sides, okay, of this triangle. I compute the angle, then if I subtract this with pi, I will get this angle, right? And exactly that is written over here. So if I have a second quadrant, I'll use this. Don't remember it as a formula, remember it as a concept, right? This is a concept, because like if you remember as a formula, you will forget it. But if you remember why did I do pi minus theta, then you will always remember it. Here also, now in the third quadrant, what is happening? Instead of going from all the way here, I'm going from all the way here. So obviously, again, right, these are the sides of triangle and this is the theta. I'm able to compute the theta. Now this is overall angle is minus pi. And this is in the anti-clockwise direction. So if I add this theta, right, I have to walk lesser. That's why minus pi plus theta, not minus theta. That's why minus pi plus theta, because I have to walk lesser amount of time. If it was minus pi minus theta, I would have gone here, right? No. Minus pi plus theta means minus pi in the clockwise direction. Then again I come back plus theta in the anti-clockwise direction, which is at this point, right? So this is the case for this quadrant. Again, for this quadrant, it is again simple. It will be simple here, right? My x is positive, but my y is negative. Again, if I compute the angle, this will be positive. This tan inverse I will get as positive angle, and I have to just walk in the clockwise direction, not in the anti-clockwise direction. That's why this will be simply negative theta, not plus theta. Whatever I will get, it will be negative theta, because I am working in the clockwise direction, not in the anti-clockwise direction. So I hope you got the idea about angle. This I have explained many times. So if you couldn't, just rewatch the video, right? You will be able to understand. Just hold on a second. I have to take a medicine because something is happening with my throat. So how will you solve this question? First of all, you have to understand which quadrant am I lying. For both of this, right? So you can also solve for yourself. So this does need to be z equals to, this can be simply a minus 1 and I, right? So if I draw the quadrant, so all this, right, you should do within your head mentally. As I'm solving it for the first time, this you have to this I'm explaining it so solely. I'm explaining it visually as well, but all this, right, should be in your mental head. Not you shouldn't write this down. This will be waste of your time, right? So first of all, you have to understand which quadrant am I lying. This, right? This means x is negative and y is also negative. Minus 1 minus I. So obviously I'm lying somewhere around here, right? So in this quadrant, my x is also negative, my y is also negative. So this is which quadrant? This is quadrant 3. Okay. So now my triangle will be somewhat like this. And if I find this theta, right? What will be my argument? Argument will be, if I rotate minus theta and if I again go in backwards anti-clockwise plus theta, if I rotate minus pi and then again I rotate plus theta clockwise, it will be minus theta plus minus pi plus theta, which will be my actual angle from this positive x-axis in the clockwise direction. So that is what I have to compute. So first thing, you understood what you have to compute, right? So what you can do is, first you have to find theta. You can't do it like this, that your argument of z equals to simply tan inverse y upon x, which is minus 1 upon minus 1, which is what is tan inverse 1, which is pi by 4, right? Pi by 4. So you can't do this. Okay, this is wrong. That's why you are observing that pi by 4 is where? Pi by 4 is somewhere positive. My point isn't even lying there, right? My point is lying in the third quadrant. So obviously you should be careful about this. So first we'll compute theta. It will be tan inverse mod of minus 1 divided by mod of minus 1, which is equals to pi by 4. So it will be equals to pi by 4. Okay, theta is pi by 4. That is fine. Theta is just the angle of the triangle, which will always be positive itself. So now what will be my argument of z? My argument of z will be minus pi, as I am going in the anti-clockwise direction, plus theta. Minus pi plus theta. So my argument of z will be minus pi plus pi by 4, which is simply minus 3 pi by 4, which is my answer, right? So you see, right, what is the actual answer, because I'm rotating somewhere less than pi, okay, in the clockwise direction. That's why the angle came like this. So from the angle result itself, we can also approximate that my answer is correct or not. So this is the case. Now let's go to this, right? In which quadrant is this lying? So like if you just solve it normally, just what many students do. So what they will do is they will directly write tan inverse minus, what is this? Tan inverse root 3 is positive plus root 3 divided by minus 1. So it is simply what? Minus tan inverse minus root 3, which is minus of pi by 3. Minus of pi by 3 is somewhere around here, right? Here. Am I really lying around here? This is what? Minus of x and plus of root 3. I'm lying around here, and the angle that it is giving, tan inverse like y by x, is here, right? Which is simply wrong. Right? So obviously you have to identify the quadrant. So this all these things you should do in your mind, obviously. Like this much time you can't waste. I'm just explaining, that's why I'm wasting this much time. So you find the theta first. What is theta? Theta is tan inverse mod of root 3, then mod of minus 1. Okay, so it will be pi by 3 simply. And what will be my this value? This value will be, if I move total pi and if I subtract it with theta, I will get my angle with respect to positive x-axis in the anti-clockwise direction. So this will be, so my argument of z will be pi minus theta, pi minus pi by 3, which is 2 pi by 3. Okay, so you have to be careful about this, and this is not the argument, this is a principal argument. If I add 2 pi with it, I can get another argument, right? So this is a principal argument. Okay, so I will write here, principal argument should always lie between 2 pi minus pi to pi, but any other, right, they can lie anywhere. If I add 2 pi with it, it's the same thing, right? I'm just rotating a complete circle. It's the same thing. So that's why principal argument. So it is also very important to understand this, that this will be principal argument. Okay, so now let's like move on to the next concept, that it is basically represented in complex plane, right? Polar complex plane. So how do you represent it in polar complex plane? So basically, if I have in the Cartesian format, first what I'll do, I'll compute the distance from the origin. How can I compute? So I have a point here. First I have to compute this this distance from the origin, which I can compute with the modulus of z, or basically with the Pythagoras law. So this will be what? This will be mod of z. What is mod of z? 5 by under root 2 whole square plus 5 by under root 2 whole square whole under root, which will be simply 5 itself. So it will be 5. And what will be this? Now here, right, you have to find the argument. So this theta, right, it will be argument of z. So you can write it like this also, that is fine. Okay, you can write it like this. No, you have to find the argument. So what is this? What will be theta? So theta, right, if I just write my theta will be, in which quadrant am I lying? I'm lying in the fourth quadrant, right? I'm lying in the fourth quadrant. So where my y is negative and x is positive, right? Y is negative and x is positive. So it will be minus theta. So basically it will be minus theta. So minus theta means it will be what? You can directly compute theta is mod of 5 by root 2 by mod of 5 by root 2, which is minus mod of minus 5 by root 2, which is tan inverse 1, which is pi by 4. But theta is minus pi by 4, right? Because sorry, my argument of z is minus pi by 4. That is the more important part. Okay, so cos of this will be minus pi by 4. So cos of minus pi by 4 plus I sine of minus pi by 4 okay. So this will be what? This will be minus I sine pi by 4, right? And this will be cos minus theta is cos theta itself, right? So you can come back to this again, right? You can come back to this again. Okay, so you will see, you will get the same results. But what angle I have to move? I have to move minus pi by 4. So I have to move here, right? So obviously, first of all, I will in the Cartesian complex plane I'm lying here, right? I'm lying somewhere around here. The distances are equal, although it doesn't seem so. Okay, but they are equal, trust me. Okay, so this is my point P, which is 5 by root 2 comma minus 5 by root 2. In the polar plane, what I'll do first, I will try to draw a circle of radius 5. If I draw a circle of radius 5, okay, then I will move that amount of angle from the positive x-axis of the argument, right? Argument. So I will draw a pointer from the origin of distance 5. Then I will move along, right? Move along the x-axis. In which direction I have to move? It is telling me I have to move in the minus pi by 4 direction. So I will move here, minus pi by 4 direction. I will be present over here, and exactly that will be my location of my point. Okay, this will be P, which is r comma theta, which is r is 5 and theta is minus pi by 4. This distance is 5 and this theta is minus pi by 4. So this is how you represent in complex polar plane. So these are very simple things only. So graphically, what do you understand by conjugate? Basically, it is nothing but the image across the positive x-axis, right? So if it is given x plus iy, the z conjugate will be x minus iy. But do remember, it will not be on, like, imaginary number will not always be positive, right? It can be given like this also. For some reason, if my z1 is given like x minus iy, so z1 conjugate is also like this, x plus iy. Okay, you just interchange what? You just interchange i2 minus I. This is the most important concept for conjugate. Whenever you're taking the conjugate, for conjugate, what you do? You just simply replace I2 minus I. Nothing else you need to do. In the whole equation, there may be like numbers with weird numbers, right? Weird equations. What do you do? Like, obviously, all the coefficients should be real. And then you replace I with minus I for conjugate. Just this simple trick you have to remember. If you have to find the conjugate, just replace I with minus I. Okay, for conjugate, wherever there is I, you replace it with minus I. If I have minus I, you will replace it with simply plus I, because minus 1 times I, and I is replacing with minus I. Okay, so this is the case. So, like, few more properties we have to understand for complex numbers, which, you know, obviously, like, if z1 is equals to z2, this I've already told, real of z1 is equals to real of z2. This I've already told, right? So this I don't need to write here again, but this, right, these properties are important. Like, your z will never be equal to z inverse anyways. Z inverse is something else that I will talk about here. It is basically 1 by z. 1 by z, it is not equals to z, that we know already. And z bar, right? What is z bar? Z bar is simply x plus iy into x minus iy. If I do the simple multiplication, it will be simply x square plus y square, which is also equals to mod of z whole square. This property is very, very important property. This will get used multiple times. Okay, this is very important, but you have to understand this property, and obviously you can, like, remember this, but don't need to remember, right? This simple derivation, right? X plus iy into x minus iy is x square minus I square y square. I square will be plus, so x square plus y square, which is simply mod of z whole square. So that is the first thing. Next is this, right? Next is this. So this is z bar. basically if I take the conjugate of z, then again I take the conjugate of z. So if I'm replacing I with minus I, then again I replace I with minus I will get back the same number itself, which is plus z itself, right? I will get back the same number itself. Okay. Now, if my z is equals to z conjugate, even if I replace I and minus I and I'm getting the same answer, basically what is happening, z is purely real. There is no imaginary part, because even if I'm replacing interchanging the imaginary parts, nothing is changing with z. Obviously z will be purely real, right? You can check this observation, right? You can check the example z is 3. Okay, now if I do z bar will also be 3. But if z is 3 plus I, okay, if I do z bar, z will be 3 minus I, which are not equal. So obviously if z is purely real, this property will always hold, and this is also very important property, right? Like in quotients, they will not give this, they will give this in terms of variable, and from this you have to decode that they're meaning that z is purely real if they are writing it like this. If they're writing that the conjugate of a number is equals to that number itself, that means they're trying to say that the number is purely real. Okay, so you have to decode from the quotients. Now next, if z is equals to minus of z bar, then it is purely imaginary. Let's take another example. Z, let me take a purely imaginary number which is plus 3i. If I compute z bar, it is simply minus of 3i, right? As the real part doesn't change, but the imaginary part will change. So imaginary part changes. So if the imaginary part changes, that means this is minus times this. If I just multiply minus with it, this two will become equal, and exactly that is what written over here. So if in the quotient they have given that the conjugate of a number is equals to negative of the number, that means he is trying to tell you that the number itself is purely imaginary. There is no real terms present in the number. Okay, I hope you got the point. So these are few points, like pretty simple to understand. So if I add z plus z bar, right, what will happen? I will add x plus iy plus x minus iy, which is 2x. Basically x is what? X is the real of z, which is exactly written over here. Similarly, you can do the derivation for this same thing. Now, if I apply the conjugate of addition of two numbers, I can divide that, right? I can divide that individually. I can take the conjugate of the individual numbers and then add those two ups. So these things you have to like understand the properties. And if I am taking the conjugate of two numbers in multiplication, I can individually take the conjugate and then do the multiplication. If I am taking the conjugate of two numbers and doing the division, then I can individually do the division. Obviously z2 can't be equal to 0. In the previous case also, right, when I was explaining the division case, here obviously x2 and y2 can't be equal to 0. Okay, this is the first case, and okay, these are few properties. And if I am taking the power of some z number, first I can do the conjugate and then I can take the power. It's the same thing only. Okay, these are a few properties you have to just understand, okay, with complex numbers. Now let's solve this question. So if four complex numbers z bar minus 2 real of z bar and z minus 2 real of z represent vertices of a square of side 4 units in the argand plane, then what is my magnitude of z? So to already obviously understand this, right, what I have written. So if you don't understand anything, just start from basics. You start with z equals to x plus iy. Okay, so obviously it is talking about square in argand plane, so I will also draw the argand plane side by side. X iy. Okay, so what is z? Z is x plus iy, so I will assume that my x and y are both positive. Okay, I will assume this. I have to assume something, right? X and y are both positive. So x and y are both positive. Then this point, right? This first point, because x is a fixed point here. No, it's not a variable anymore. It is a variable, but it's lying somewhere around here, right? That I have set the reference. I have set the reference. So it will lie somewhere around here. So this is x comma y. Now z bar represent the vertices. Z bar is also a vertices of a square. So what is z bar? Z bar is simply the mirror image of this, right, about the x axis. if I write it in terms of equation, it will be z bar equals to x minus iy. So it will be somewhere around here. Okay, so it will be somewhere around here. So this is the case. Next, what is the case? So this is another vertex of a square. It is a mirror image about the x-axis. So this distance and this distance will obviously be same. This distance is y and this distance is also y. So overall this distance will be 2y. Now what is this? Z bar minus 2 real of z bar. So what is z bar? Z bar is this. What is 2 real of z bar? Real of z bar is x. I am subtracting 2 times this. So z bar minus 2 real of z bar is simply x plus iy minus 2x, right? Real of part of z bar is x only. So it is 2, it is minus x plus iy. Okay, so I will just take this to the next page. So what is this? This is basically what x is negative and y is positive. So I am lying in this quadrant. So this is the point, right? This is minus x plus y. Okay. Now what about the other case? What about this case? It is z minus 2 times real of z bar. Real of z simply. So z minus 2 times real of z is what? So z is x plus iy and real of z is what? Again x. So z will be, oh, okay, just hold on. Yeah, okay, have I made any mistake over here? Okay, my apologies. This will be minus iy, right? So this will be minus iy. So this point, right, will lie here in the third quadrant, not in the second quadrant. Okay, so this will be minus iy. Okay, so this is the case. Now like this will be minus iy, sorry for that. This will be plus iy, right? This will be simply minus 2 minus x plus iy. Okay, so this will be here. I will lie somewhere around here, right? So this will be minus x plus y. Now what is important? The important is these are vertices of a square. So the distance between all the vertices will be same. So if I just connect this, right? Connect this, then I connect this. So what will be the distance basically? The distance, this, right? Okay, it is not up to the scale, but I hope you are able to understand. Yeah, the distance, this distance is what? This is y, right? Okay, the height is y from the positive x-axis. This is the y distance, and this is also y because this is a simply mirror image. So overall this distance will be 2y. Similarly, same case, from the x-axis this distance is x, and this is also x, right? Because this is negative x. So overall distance is 2x. Okay, so overall distance is 2x and 2y. So they have also given me, right? They have also given me the distance of 4. So obviously 2x will be equals to, according to the quotient, what have they asked by the way? Mod of z, right? So 2x equals to 4 and 2y equals to 4. So for mod of z you need the value of x and y. X square plus y square under root, that is mod of z. So x will be equals to 2, y will be equals to 2. So mod of z will be under root x square plus y square equals to so what will be this? This will be 2 square. So this will be 4 under root 2. So this will be my, okay, no, not 4, sorry, this will be 2 under 2, right? 2 under 2. Okay, 4 plus 4 is 8, and if I take the under root of that, that will be 2 under root 2. So like it is given in the option C. So this will be answer. So like that, like this, these type of questions may come, right? Basic questions. So now we'll understand one more important topic, that is the Euler's representation. So what is Euler's representation? Basically, Euler's representation is that I can write my cos theta plus I sin theta as e raised to power I theta. That is what Euler has told us. So like you can sometimes prove it also. Like cos theta is what e raised to power I theta plus e raised to power minus I theta by 2, and this is e raised to power I theta minus e raised to power minus I theta by 2i. 2i gets cancelled, and at the end you will be left with e raised to power I theta only. Okay, so you can prove it like that. So that is what Euler has told us, that you can simply write this as a single term, and this helps us in computing the multiplication, division, and many more applications, right, in a much more simpler manner. So if I write e raised to power minus I theta, then what will be it? It will be simply cos theta, because minus theta is cos of minus theta is cos theta itself, and sin of minus theta is minus sin of theta, so it will be minus I of sin theta. Okay, so it will be conjugate, and this will be plus I, right? So now, what are the important properties of this e raised to power I theta? If I find the magnitude of this, right, what will be the magnitude? It will be cos square theta plus sin square theta, which is always 1. So the magnitude of this is always 1. So if someone is asking you the magnitude of this, right, magnitude of 3 e raised to power I theta, it will be magnitude of 3 into magnitude of e raised to power I theta. Magnitude of e raised to power I theta is 1, so it will be 3 itself. Okay, so just delete this. I'm just showing you one example. Now, if my e raised to power I theta is this, then what is my, like, I will write few standard forms, right? What is my e raised to power I pi by 2? E raised to power I pi by 2. What is it? It is simply theta equals to pi by 2. So theta is pi by 2. So cos of pi by 2 is 0. Sin of pi by 2 is 1. So it is 0 plus I into 1, which is I itself. So e raised to power I pi by 2 is I. E raised to power minus I pi by 2 is minus of I. Then like what is e raised to power I pi? E raised to power I pi is what? Cos of pi is minus 1, sin of pi is 0. So it will be minus 1. E raised to power minus I, e raised to power minus I pi, e raised to power minus I pi is 1. Okay, so this is about the total configuration, right? Plus I, minus I, minus 1 plus 1. Okay, all the 4 terms that I have written. So like this also you should remember, right? Next is conjugate. Like this is basically the conjugate, right? If I want to write the conjugate, I will just replace I with minus I. Exactly that thing I have done, right? Exactly that is what I have done. I just replace my I with plus I. So this is basically conjugate. Replace I with minus I. Okay, so these are the few notations. Now if I want to write in polar form, right, as the Euler representation, this U should be capital. So what will be it? It will be simply x plus iy can be written as r cos theta plus I sin theta, that we have already learned, and I can further write it, this term I can write it as e raised to power I theta. Okay, so this has become so short now. Okay, and this helps in many computation. And what is the value of this r? We already know it is simply mod of z. It is mod of z, which is equals to under root of x square plus y square, which will always be positive. It can never be equals less than 0, right? It has to be always greater than or equals to 0. Okay, so now let's understand the properties of complex number. What are the few properties of complex number? So like we have already learned this, and like again we are doing this. So basically the product of these two, right, z1 z2, it will be simply if I do the mod of this, so I can individually do the mod of each of them, and then I can multiply the mods. Like basically while doing this, right, you can convert it into Euler's format. What will be it? It will be r1 e raised to power I theta, r2 e raised to power I theta 2, theta 1 theta 2. Now it will be r1 r2 into e raised to power I theta 1 plus theta 2. Now magnitude of e raised to power I whatever, right, I can name this as theta 3, that will be 1, and I will be left with r1 r2, which is simply the individual multiplication, right? r1 r2. Magnitude of z1 is r1, magnitude of z2 is r2. Simply proof. Again here, right, if I take the mod of z1 by z2, you can again break it down. You can again break it down in Euler's form, right? And this is important. If I find the argument of z1 times z2, what will be the argument of z1 times z2? So if I am finding the argument of z1 times z2, what will be it? Basically, e raised to power I theta, if e raised to power I theta 2. So power will get added, right? So theta 1 plus theta 2 will be the final expression of my complex number. So obviously the argument will be the angle with I, which my e is with the power. So it is theta 1 plus theta 2, exactly what is written over here. Argument of z1 is theta 1 plus theta 2. These are simple things, right? I hope you can understand. This I divide, they will become theta 1 minus theta 2. That's why it becomes like this. So if you understood the properties, like these are the properties, I hope you can understand those. Find the argument of z1 over z2 if z1 is equals to 5 plus 5 root 3 and z2 is 3. This, right? So obviously, if I try to compute z1 by z2, right? If I try to compute z1 by z2, it will be very complex for us. Okay, in the rectangular format, in the Cartesian format. Plus 2a. Okay, so this is the case. So if I try to do this, it will be difficult. Now if I basically if I convert this, like I will show it this as complex, right? Complex we are studying complex numbers, and solving this is complex. So what I will do, I'll convert this into our Euler's format, or you can say Polar's format. So what will be z1 in Polar's format? So what is the magnitude? Magnitude is 5 times 2. You can compute 5 times 2, which is 10. And what is the angle? As everything is positive, right? I can simply write theta is equal to tan inverse y by x. Everything is positive. So it is 5 root 3 by 5, which is tan inverse root 3. So if it is tan inverse root 3, what is tan inverse root 3? It is 60 degrees, which is pi by 3. And what is z2? Z2 is, if I take the square and then do the under root, right, it will be 2 will be outside, 1 by 3 plus 1, which is 4 by under root 3. Okay, 4 by under root 3. So which will be 2 by under root 3. So this will be 4 by under root 3. So magnitude, all this you can compute, right, in one step. And what is the angle again? It is 2 upon tan inverse, everything is positive, tan inverse 2 upon 1 by root 3, tan inverse 2 by root 3, which is root 3 itself. So again the angle is pi by 3, right? So now if I want to compute the argument of z1 by z2, simple, it will be the subtraction of these two, which is pi by 3 minus pi by 3, which is 0. So just you look how simple it is, right? So if I had to compute the argument here, like I have to do the cross multiplication, all these things, right? That will be very calculative, time consuming. But here, right, if I convert it into Euler's format, I can solve everything just seconds. So this again, right, this you can do it two ways. Either you can use Euler's method, or you can use the method 2, which is simply cross multiplying and making the denominator real part, okay, and then separating the real and imaginary parts. So we will try to do this using two methods. Method 2 I will give you as homework. I will convert here in Euler's format. So what is Euler's format? So if I convert this into Euler's format, this will become 2 plus I. So 2 square plus 1, which is under root 5 e raised to power I theta 1. For now I will write theta 1, okay. I will calculate all these things later on. And this is what? 3 square plus 1, which is under root 10. And this is e raised to power I theta 2. And just remember, this is negative and this is positive. So you have to remember that, right? This is in which quadrant? This is in the fourth quadrant. So it will be minus theta. And this is in the first quadrant. It will be plus theta whole square. Okay. So basically it is 1 by under root 2 whole square. So this will become 1 by 2 and e raised to power I 2 times theta 1 minus theta 2. Now what is my theta 1 minus theta 2? It is very important. So my theta 1 is, just hold on, let me put this in charge if I can. Okay, this is already full charge. I will just put this in charge. What is my theta 1? I will just compute the theta 1. It is basically 1 by 2, right? And 1 by 2, tan inverse 1 by 2, what I remember, it is basically 26 point, is it 26.56? Just let me compute here. You should remember tan inverse 1 by 2 also. If I just do this, tan inverse, yeah, it is 26.56. This you have to remember, right? This also is helpful sometimes in examination hall, because in control systems also we use this tan inverse 1/2. So 26 point, this is 5.6 as is in the first quadrant. This is positive. Now basically what will my theta do? Theta 2 will be as is in the, remember this is in the what, fourth quadrant, right? Fourth quadrant. So it will be negative of tan inverse of 1/3. So what is 1/3? Just do this. 18.43. But it will be negative here. That is the more important part. 43 degrees. Now I can plug in the values over here and I can compute this, right? So I have to compute this, right? I have to compute the square of this. So this, what will this become? So this plus 26.43. Okay, no. Plus 26. So this almost becomes 45. So what does it become? This becomes 1/2 e raised to power I 90, which is basically pi/2. I'm writing in radians pi/2, right? And what is e raised to power I pi/2? I just these are the four most important arguments, right, of Euler format results. So e raised to power I pi/2 is I itself. So at the end I am getting I itself, right? I, which is equals to I, so it will be I/2. And is there any option present in I/2? There is, right? So option C will be my correct answer. Now what is the method 2? Method 2 is I'll just initiate the method 2, which is also good, but like this one is better, because this one will always find you any values. We don't have to use any tricks. So method 2 is simply like rationalization, right? This is 3 minus I. So what I will do, into 3 plus I into 3 plus I whole square. Now if you like solve this, you will get the same results. Okay, still like it will, in this case it will take the same time, but in some cases that may be easier. So another question that came in GATE EC paper 2012, they have given x, like x is under root of -1, which is basically I itself, right? Then the value of x raised to power x. Okay, what are they asking? They are asking x raised to power x, but we are more comfortable with I, so I will write I as x as I. So they are asking me to compute the value of I raised to power I, which is a bit difficult for me. Okay, I don't know all this. So what I'll do, I will just replace this, right? I will replace this with exponential. I will replace this with exponential. I will keep this as I, but I will replace this with exponential, because exponential to the power something is more, I can handle those things more, right? Better, in a better manner. So what is I? I is e raised to power I pi/2, right? I have already mentioned that. You have to remember these important results. So it will be I pi/2 into I. So basically I times I is -1, like as power gets multiplied, right? So what will this become? This will become e raised to power minus pi/2. So it becomes e raised to power minus pi/2. So here also there is one option present, right? E raised to power minus pi/2, e raised to power plus pi/2 x. Will it be I itself? No. Will it be 1? How can it be 1? Like there is imaginary numbers everywhere. How it can be 1? So it will be this, right? It will be e raised to power minus pi/2. But like, okay, I raised to power I, you are getting a real number itself. Sorry. So you can get anything, right? You can get anything. You can get 1 also. Because I raised to power I, this is a real number, right? This is a real number. Because this I is getting multiplied with this. So this is a real number. Real number. Okay. So yeah, this will be the answer. Option A will be the answer to this question. Okay. So like let's solve another basic question. So if you have to find the modulus and argument of z. So I have mentioned one thing. What have I mentioned? Like the given complex number, modulus is, I can see the modulus is negative. Is it possible that I get negative modulus? No, it is not possible that I get negative modulus. My modulus, mod of z, is always greater than 0. So how can I write my complex number? I can write my complex number like this, right? Mod of z into angle of z. I can write it like this. So this there is a minus sign over here. I want to remove this. Do I know how to remove minus sign? What is -1 in terms of exponential? So in terms of exponential, right? In terms of exponential, I have told you one important result, that e raised to power I pi is -1. So that's why I already told at the starting of this, right? That you have to remember this result. like you don't have to even remember, right? These are like basic things. So e raised to power I pi is minus 1. So I can replace this minus 1 with e raised to power I pi. So if I replace this minus 1 with e raised to power I pi, I will get this e raised to power I pi times 2 times e raised to power minus I pi by 3. Now it is fine, right? My modulus is positive. Obviously, I can add these two powers. What will be it? It will be e raised to power I pi minus pi by 3, which is e raised to power 2 pi by 3. I 2 pi by 3. Okay. So it will be e raised to power I 2 pi by 3. So now like you can find the modulus is what? Mod of z is 2 and the argument arg of z is 2 pi by 3. Okay. So this is the method 1. This is the method 1, which is the Euler's method. Okay. Is there any method 2? Yes, there is, which you can use the Euler's method, but the previous one is better. Like in terms of me, I like that better. Euler's method. Euler's form, right? So what is a Euler's form? Basically, you convert this, right, into Euler form. That is, I can write this as minus 2 times cos of minus pi by 3 plus I of minus sin pi by 3. So if I write that, what will happen? So it will be sorry, not polars, actually in rectangular form. So in rectangular, we are able to identify which coordinate is lying. So from there, we can directly compute. So basically what I do, this z will be minus 2 times e raised to power minus pi by 3. So this is cos of minus pi by 3 plus I sine of minus pi by 3. Okay. So z will be minus 2 cos of minus pi by 3. What is cos of minus pi by 3? Cos of minus pi by 3 is cos xt, which is equals to 1 by 2. Okay. So this will be simply equals to 1 by 2. And sine of minus pi by 3 will be minus I root 3 by 2. So this will be equals simply minus of 1 plus I root 3. So which quadrant am I lying? I'm lying in the magnitude. We can already anyways find out, right? It will be 2 itself that we can find. So this is in the what? Second quadrant. Second quadrant. Now if you remember, what was the angle formula for second quadrant? Basically it was my arc of z was pi minus theta. So what is my theta in this case? Theta is tan inverse mod of root 3 by mod of minus 1. So which is pi by 3 itself. So it will be pi minus pi by 3, which is exactly what we got previous case, which is 2 pi by 3. So this is how you get the answer, right? This is how you get the answer. So it is very important to understand like in which quadrant am I lying, and also cos minus theta and sin minus theta. These things also you have to understand, right? So yeah, these are the few important things that you got to understand. So yeah, that's it for this question basically. So let's move on to the next theorem, that is the de Moivre's theorem. So what is the de Moivre's theorem? It's nothing. Basically he has used the Euler's identity to do all this. So I can write my any number, okay, like only if it is in the form like this, as cos theta is purely real and plus minus I sin theta. Sin theta is with the imaginary term and cos theta is with the real term. So if I raise it to the power of m, what will happen? This m, right, will get multiplied with the theta simply. So it will become cos m theta plus minus I sin m theta. M will get multiplied with the theta, where m can be any integer. Okay, m can be anything actually. M can be anything. Okay. Why? Basically, how you can write this, right? How can you represent cos plus minus I sin theta? We have already done this, right? Just previously in previous 2 slides, which is cos theta plus minus I sin theta equals to e raised to power plus minus I theta. That you can write. And obviously, I am raising it to the power of m. So I write this, raising it to the power of m. This also. So this will be what? This will be plus minus, like I'm raising it to the power of m, so powers will get multiplied. This will be plus minus I theta m. Okay, this will be plus minus I theta m. Now again I can revert it back to the polar format. So this is theta m, so my theta, right, theta dash is theta m, theta times m. So obviously this becomes cos of theta m plus minus I sine of theta m. So this is the simple proof, right? Simple proof that we got. Okay, so like we write m first, then theta. So just the representation basically. Okay, so what point is important is that what you can't do, which things you cannot do. So basically, if I have been written like this, sine theta plus minus I cos theta, if I raise it to the power of m, will it be equals to sine m theta plus minus I cos m theta? Will it be equals to this? It will not be equals to this, because it is not the correct format, right? So our I should be with the sine for theta, and real terms should be cos theta, because then only we can convert into this Euler format, and then only we will be able to write this representation. Okay, so this is also not possible. What you can do, you can multiply and divide I, and you can take the help of that, but else that you won't be able to do. Another important point is that if I have something like this, that this is cos theta plus minus I sine phi raised to power m. Again, can I write this like cos of m theta plus minus I sine of m phi? Can I write this? No, right? I cannot write this. Why? Because this again, right, I can't convert it into Euler's format. That's why. Simple. Like this was the proof, and if I'm not able to perform the proof, obviously this relation won't follow. So obviously I will write here theta is not equals to phi. Okay, so these two you have to keep in mind, that you just don't blindly use this theorem, right? You have to understand when to use and when not to use. Obviously, as the proof is very simple, you can understand when not to use. Only when we are not able to convert into Euler's representation. अरे यार सिलेक्ट नहीं हो रहा, ये क्या हो रहा है? Okay, here only. Okay, so this is a general format of de Moivre's theorem. So now, right, if I have different angles, okay, if I have different angles, and if I multiply these two, right, if I'm multiplying this, but these angles are same only, these angles are same, so what will happen? Basically it will be theta 1 plus theta 2 plus theta, and simply like what I'm doing, I'm simply doing this only, right, which is e raised to power I theta 1 into e raised to power I theta 2 into e raised to power I theta 3, and it is going on till e raised to power I theta n. So obviously what will happen, as it is getting multiplied, powers will get added. Okay, as I'm able to convert it into exponential format, it will be e raised to power I theta 1 plus theta 2 theta n. Okay, theta n. Okay, it will be theta n. So that is how it like our de Moivre's theorem will look if I'm multiplying different angles, right? Then like simple proof only. So let's solve this using that proof. So if alpha and beta are roots of this equation, okay, alpha and beta are roots of this equation, fine. Then find alpha raised to power n and beta raised to power n. So this can be solved using other ways also, but let's solve using our complex number thing. So if alpha and beta are roots of this equation, then alpha and beta has to satisfy, and let us compute the roots of this equation. What is the roots of second order equation? Simple, right? It is alpha beta will be equals to minus b plus minus b square minus 4ac. 4 times 2 is 8 minus 8, right, divided by 2a. So minus 2 plus minus what is this? Under root of minus 4, which is I 2 divided by 2. So it is minus 1 plus minus I. Okay. So alpha, like I can assume alpha is anything. Alpha is minus 1 plus I, and beta, let's say, is minus 1 minus I. Now what you can do? Now there are two ways to go about this. So either you can compute alpha raised to power n and beta raised to power n. Okay. Either you can compute that, like you can square it, cube it, then you can find a pattern, or you can directly convert it into Euler's format, okay, or do Moivre's theorem. So basically, what is this? What is this? Can you tell me what is this? Minus 1 plus I. Can you convert it into our polar format? Can you convert it to that? It will be simply, but like anyways, I can convert it to directly Euler's format and I can directly get the results, but let's convert it into polar format. So minus 1 is cos of pi. Okay, cos of pi, but I have I also here, so it can't be equals to cos of pi. So what can it be equals to? What is the magnitude? Magnitude is root 2. Magnitude is root 2. Okay, and if the magnitude is root 2, then what will be the angles? So basically, if I write here cos of this will be minus 1 plus, this will be 3 pi by 4, right? If I write here root 3, no, not root 3, if I write here root 2, if I take root 2 common, this will be minus 1 by root 2 plus I into 1 by root 2. Now what is this angle? That is what I am thinking about. So this is, okay, sorry, this was actually plus. That is what I am thinking, right? This must be something mistake that I am doing. This will be plus, this will be plus, so this will be plus and this will be plus. Okay, now it is fine. So this is simple, right? What is the magnitude? Root 2. So I take common the modulus, then whatever this is, right? This will be basically the theta. So cos of theta is 1 by root 2, so theta equals to 45, and this also satisfies that. So obviously I can write it like this: root 2 times cos of pi by 4 plus I sin pi by 4. Okay, so this will be I sin pi by 4 for alpha, right? This is alpha. Okay, and how can I write my beta as? So my beta, right? Let me take this here and let me just reduce the size of these things. So beta, I can write, now this is plus, but this is minus. So this is what? This is something like cos of minus theta. So if I do cos of minus theta, it will cos theta, but sin of minus theta will be minus sin theta. So this, right? Or you can find, like, compute the argument, right? You can compute the argument. It is in the which quadrant? It is in the fourth quadrant. So it will be minus theta basically. Okay. So like that you can do. Again, I am taking root 2 common, and like argument is what? 45, minus 45 degrees. This will be cos of minus pi by 4. Okay, so we'll write this here, cos of minus pi by 4, and or you can write it like this: I sin pi by 4. Okay, so I'll just reduce the size of this. So this becomes this one. So now they are asking us to compute alpha raised to power n, beta raised to power n. So I can compute, right? I can use the Moivre's theorem. So what will be my alpha raised to power n? Alpha raised to power n plus beta raised to power n will be nothing, but n will get multiplied inside, right? N will get multiplied inside. So this will be root 2 raised to power n. Okay, or I can write it as 2 raised to power 1 by 2 times raised to power n, which is n by 2. And this will be what? Cos of n pi by 4 plus I sin of n pi by 4, and this will be what? 2 raised to power n by 2, and this will be cos n pi by 4 minus I sin n pi by 4. So what is happening is that if I take this 2 raised to power n by 2 common, right, this will get cancelled. Okay, so I will have 2 times this. So my final answer will be 2 raised to power n by 2 times 2 cos n pi by 4. Okay, so this will be 2 raised to power n by 2 plus 1 cos n pi by 4. This, right, this you can do with Euler's also. So this will 2 raised to power n by 2 plus 1 into cos n pi by 2. So option C will be your correct answer. So like another easy method is using, instead of using de Moivre's, right, you can simply use Euler's. Okay, so method 2 is simply use Euler's. Okay, no need to follow all this. Like if you are not able to like this is like the proof is from Euler's itself, right? So simply use Euler's if you are like, if you think that this is too long. So next is another topic, that is cube root of unity. First we learn cube root of unity, then we learn nth root of unity. So we know square root of -1. Okay, and so what will be cube root of -1? Cube root of what will be cube root of 1? You might say, sir, it will be 1 itself, right? I will say yes, it is 1, but is there only one, like one solution? Because while I do square root, right, I will get 2 solutions. So let's say I am doing square root of 1. I can get plus minus 1. Why? Because if z is equals to square root of 1, I can do z square equals to 1. So what value of z can give me 1 if I square it? Plus 1 can also give me 1. Minus 1 square also can give me also 1. Okay, so to understand this, so both of these can give me 1. So I am getting 2 roots. Now if I am doing finding cube root of unity, I should get 3 roots. So basically I can rewrite this equation like this, which is z, I am taking the cube on both sides, z cube equals to 1. So cube of z is 1. Okay, cube of z is 1. Now if I manipulate this equation, z cube minus 1 equals to 0. Now during your childhood, right, you must have remembered the factorization of a cube minus b cube. What was it? It was simply z minus 1 a minus b into z square plus ab, which is z plus b square, which is 1. Okay, so this was the factorization. So whatever solution you are given till now is for this. Z equals to 1, this equation gets 1. But even if z is not equals to 1, right, if this is equals to 1, then also, sorry, if this is equals to 0, then also I can get roots, right? And this is a quadratic equation, so obviously I will get 2 roots. I can compute the roots from here. Okay, so let us obviously compute the roots. So what are the roots? If you compute the roots, you will get the root something like this. Okay, you will get the roots something like this. You can find it out from like a simple Sridhar Acharya formula. Another important point is if you don't want to do it like this, what you can do, you can replace your 1 with what? You can replace your 1, z cube equals to e raised to power I 2 pi k, where k is my any integer, right? K can be any integer. It is 2 pi, right? So what is happening? If k is 0, it is e raised to power 0, which is 1. If k is 1, it is e raised to power I 2 pi, which is again 1. If k is 2, it is e raised to power 4 pi, which is again 1, right? So like it is going on like that. So always when you are in the topic of nth root of unity or cube root of unity, right, always try to replace your I with this, something like this. So if 1 with this. Okay, so now if I take the cube root on both sides, what will happen? Z will be e raised to power I 2 pi k by 3. Now as I have 3 roots, I'll go 3 steps. Okay, what steps I'll go? I will go for k equals to 0, k equals to 1 and k equals to 2. K equals to 0 means 1 is a root, fine. K equals to 2 means, k equals to 1 means 2 pi by 3. So what is e raised to power 2 pi by 3? You will see that this is e raised to power 2 pi by 3. Exactly what you computed from the quadratic equation solution. What is e raised to power 4 pi by 3? It is exactly this. You will see, you get 2 solutions, right? One will be e raised to power 2 pi by 3 and then will be e raised to power 4 pi by 3. Basically what am I doing? I am just multiplying, I'm just adding up 2 pi every time, right? So for first step it is 2 pi, then again I'm adding to another 2 pi, which is 4 pi. So I'm adding up 2 pi every time. Okay, so these are the roots for this, for k equals to 0 equals to 1. Now there are some properties of this root. Okay, there are very good properties of the roots. One property which you can understand is, the formation of quadratic equation, right? You know the formation of equations. What do I mean by this? If I have been given this quadratic equation, x square plus 2x plus true equals 0, you will say the coefficient of x represents the negative of sum of the roots, and the constant term represents the product of roots. In cubic equation also, the constant term represents what? The constant term represents again the negative of product of roots. The constant term represents the negative of product of roots, and the term coefficient of the term z square also represents the negative of sum of the roots. So I go something like this. So if I have been written like this, I will just write this z cube plus 2z square minus z plus 2 equals to 0. So z cube is this, right? So what will happen is that the coefficient of z square is plus 2. Coefficient of z square is plus 2. So if it is plus 2, that means the sum of roots will be minus 2, and the product of roots will be minus 2 also. Okay, this is how we use the properties, and I will show you, right? I will show you here. Okay, the properties of this. So this, right, we name this, we have a special name for this, which is omega. I hope you already know this, like you have studied in class 11th. So we name this omega, or you can name this like this, or sometimes it helps to write it like this also. Okay, so omega, and this is omega square. Basically we are squaring it again, right? And exactly that will happen for the next cases also. We will see. So what is the first property? First property is 1 plus omega square equals to 0. Basically what does it mean? It basically means the sum of roots. I will write here sum of roots. Why is that the case? You can observe from here itself, right? Here, what is the coefficient of z square in this equation, cubic equation? The coefficient of z square is 0. So obviously the sum of roots will be 0 itself. It won't be anything else. Basically the coefficient of z square is 0, so obviously sum of roots will be 0. Exactly that is what is written over here. And we already know this is a famous property. We have used this multiple times previously. Like you have also used this multiple times previously. Now what is omega raised to power 3n? Omega raised to power 3n means I am taking the cube of this, right? Taking the cube of this. So if we take the cube of this, I will be left with e raised to power 2 pi or multiple of 2 pi. So what I am doing over here, I am doing this, right? E raised to power I 2 pi by 3 into raised to power 3n. So this becomes e raised to power I 2 pi n. Okay, so this becomes e raised to power I 2 pi n. So what is this? This is simply integer multiple of 2 pi, which will always yield me 1. Okay, which will always yield me 1. That's why here 1 is written. Okay, next is omega raised to power 3n plus k. What is omega raised to power 3n plus k? So basically omega raised to power, like I can divide this, right? Omega raised to power 3n times omega raised to power k. And I know omega raised to power 3n is what? Omega raised to power 3n is simply 1. So I will be only left with omega raised to power k, and k is also any integer, right? And so omega square, I won't be able to like say what is omega square, but omega raised to power 3 is very simple, which is 1. Okay, omega raised to power 0 is 1 also. Now if I have something like this, some equation like this, is this familiar to you? This is right, exactly that is what we got in the factorization part. So these type of things, right? If you replace x with omega, what will happen? Omega square plus omega plus 1 equals 0, which is again satisfying the first equation. So omega will be a root. Also omega square will be a root of this type of equation. Whenever you see this type of equation, you have to instantly identify that the roots of this equation will be omega and omega square. Obviously you can solve like the quadratic roots, then you can identify, yeah, that is fine. If you are not able to remember, that is fine. But if you are able to remember, then this will save time in the examination hall. Now 1 raised to power r, omega raised to power r, and omega square raised to power r. What will be this? Now this I know, 1 plus omega square. If I have a r which is raised to power this, what will be this? Now the first thing you have to understand, if r is 3, let's say if r is 3, 1 raised to power anything is 1 itself, so this is anyways always 1. Omega raised to power 3, 1. Omega square raised to power 3, this will be a multiple of 3. So obviously if this is a multiple of 3, this will also be 1. So 1 plus 1 plus 1, I will get 3. So whenever r is a multiple of 3, that is 3n, I will always have the result as 3 if I add these 3. But if this is not a multiple of 3n, if this is something else, let's say 2, right? What will happen? This will always be equals to 0. Okay, so if r is equals to 1, this will be 1 plus omega square 0. If r is equals to 2, this will be 1 square, which is 1 again, omega square, okay, plus omega raised to power 4. What is omega raised to power 4? Omega cube into omega. I'm using this property. Omega cube is 1, so omega is there. So again this becomes 1 plus omega square plus omega. So this also becomes 0. You can deduce and you will get the same result. So let's solve a question here and then you will understand. So whenever these type of things are given, right, you have to identify that this is basically my omega itself. So you have to remember this. Okay, you have to obviously remember this, and you have to identify that this is my omega, right? Remember and identify this is my omega. So I is equals to under root of minus 1. So if I is equals to under root of minus 1, you know all this. So they are asking us to compute this, right? What will be this value? So I'm seeing this. So what I can do, I can directly compute, like I can write this in terms of omega. So what will be this? This will be 4 plus 5 omega raised to power 334. So always for omega, right, you try to find multiples of 3 because omega cube is 1. And for I, what you should do, we should find multiple of 4 because I raised to power 4 was 1. Simple as. So this will be also omega. So this will be omega raised to power 365. Okay, so these, right, you have to identify the pattern. This is also omega, and omega square is here. I have a negative sign for omega square. So both of these are omega, but the powers are different, right? The powers are different. So what you try to identify, you try to identify this as multiple of 3's. So I can write 4 plus 5 omega raised to power cube into 111, and obviously there is 1 omega. I just divided by 3 and I got remainder as 1 and the quotient as 111. And if I divide this by 3, what I will get remainder? Remainder will be 1 to 1 and quotient will be 2. Omega cube 1 to 1, and I have omega square as the remainder. So now this omega cube will be 1 itself. So this will become 4 plus 5 omega, because omega cube is 1 plus omega square. Now I know 1 plus omega square is this is 3 is 0, right? So if I just like write this 3 plus 3 omega plus 3 omega, so that I can write it as 0, and other remaining terms I will solve later. So I can separate out here. This will be 1, this will be 2 omega, and the other terms, right, other terms will be what? Plus, if I take the 3 common, it will be 1 plus omega square, which is equal to 0. So this will be 1 plus 2 omega. Okay, 1 plus 2 omega. Now what is your 2 omega? That you have to identify, right? What is your 2 omega? So basically omega is this, right? Omega, now like all the powers are gone, so everything is in simple linear terms. So omega is this, so I can just replace omega with this and I will be able to compute. So obviously my value will be what? This will be 1 plus 2 times minus 1 by 2 plus I root 3 by 2. So this will be 1 minus 1 plus root 3. I is obviously there. So this will be I root 3. Okay, so the answer will be I root 3 for this question. So it will be C. It will be C. Okay, now what if you want to use some other method? So this was the first method, which is using the cube root of unity. What if you don't remember this, right? What if you don't remember? So we have always our best method, that is Euler's, right? So what you do, you will just directly convert this into Euler's format. So this you are observing is in which quadrant? This is in the second quadrant. If this is in the second quadrant, what will the angle? Angle will be what? This theta will be pi by 3. Okay, and angle will be pi minus pi by 3, which is 2 pi by 3. So this will be 4 plus 5 into e raised to power 2 pi by 3 into 3 4 plus this is 3 times again the same thing, e raised to power 2 pi by 3 raised to power 365. Now what I can observe, the e raised to power 2 pi, right, will be always 1. So I have to find this, right, to compute this, and I will be able to get to my answer. So I can write this as e raised to power 2 pi and 1 by 3 I can write as here, right? It will be 1 into e raised to power what, 2 pi by 3. That's the remainder, right? And here also the same thing, e raised to power 2 pi into 1 into e raised to power 2 pi by 3. So this will become 4. This is 1 in US. And what is e raised to power 2 pi by 3? Again, right, you come back to the same place again. Sorry, this is square actually. This will be whole square, right? Whole square. So e raised to power 2 pi by 3 is what? E raised to power 2 by 3 is this, right? Which you back calculated. So I will write it here directly. 5 times minus 1 by 2 plus I root 3 by 2. Or you can directly write in terms of like sin theta and cos theta. And what is this? This is e raised to power 4 pi by 3, which is equals to theta equals to 120 degrees, right? Theta is equals to 120 degrees. So if theta is equals to 120 degrees, sorry, not 120, 240 degrees. So theta is 240. That means my cos will be, the cot is cos of 240. You can say it is the cos of minus 120. What is cos of minus 120? It is simply as cos is even function. So within plus minus, now what is cos of minus 120? It is simply minus of 1 by 2. So it will be minus of 1 by 2 because like you can compute, right? Cos of 120 will be minus of 1 by 2. This is 3. And what is sine of minus theta? Sine of minus theta minus sine theta, and it is simply minus of like sine of minus 120 will be minus of root 3 by 2. Because you can compute sine of 240. Like that also you can compute, right? Whatever. Or you can just drop in your calculator, just press what is sine of 120, what is sine of 240, and what is cos of 240. If you are forgetting everything, right, you can just use your gate calculator, because in gate calculator that is possible. Okay, so that you can do. So what will this become? Okay, I was just computing. So this, right, this will become 4 plus 5, and this is minus 5 by 2, and minus 3 by 2, and this will be plus 5 by 2 into root 3, and I is obviously here, and minus 3 by 2 into root 3, and I is obviously here. So this will be simply I root 3, right? This will get cancelled because this will be 4 minus 4, and this will be 5 minus 3 by 2, which is 2 by 2, and I is there, and it is root 3 also. So it will be I root 3. Okay, so it will be I root 3. So this will be your answer to this question. So this is how you can solve if you don't know omega. So let's solve another question, which is this one, right? So this one is with the properties of omega itself, which we have just studied, right? What we have studied? We have studied if this is written like this, and if my R is a multiple of 3, the result will be what? Result will be always 3. If the R is not a multiple of 3, result will be 0. That we have just studied the property. So when is R multiple of 3? R is multiple of 3 when R is equal to 0 also, because 0 times 3 is also 0. Okay, so if R is 0, you can observe that 1 plus omega raised to power 0 is 1, plus omega raised to power 0 is 1 is 3. So don't forget R equals to 0. Okay, so R equals to 0, then R equals to 3, then R equals to 6, and R equals to 9. So I have 4 of this where R is a multiple of 3. So whenever R is a multiple of 3, this will always satisfy as equals to 3. Okay, so I have 4. So 4. So this answer will be 4 times I will get 3, right? And this is in summation. So 4 times 3. So I will get 12. And for the rest of the time, when R is equals to 1, when R is equals to 2, rest of the time, this will be 0. That I have already shown in the property. So else 0. So my answer will be this, simply this, right? 12. My answer will be 12. You can prove answer will be 12. So what I am doing, I'm just adding up, right? So 1 plus omega cube plus omega raised to power 6 will give you 3. 1 plus omega raised to power 6 plus omega raised to power 12 again will give you 3, because this will also be 1, this will also be 1. So overall I'll get 3. Everything else other than that will always yield you 0. Okay, so that is how you compute this. Now next is you have to find the cube root of minus 1. This is also a very interesting question, right? These questions may come up in gate examination. Okay, these type of questions. So I'm telling you, and even if you're not able to solve this question, right, don't worry. This is a bit on the higher side, high level side, like JE side. But at a later stage, right, one day or the another, they will give this type of question. Because right now, from simple topics, they are giving you like gifting you gifting you marks, right? Just giving you so simple questions, but slowly they will also increase the level. That is what the gate like the professors are doing. So obviously the level will increase, so the level of questions will also increase. So you have to also study good questions, right? Good type of questions. So you have to find the cube root of -1. What will be the cube root of -1? So whenever you have to find any root, right, you just convert that into your Euler format. So I have to find cube root of -1. So how I can write my -1? I can write my -1 as this, right? E raised to power pi. Like my -1 I can write as e raised to power pi, but but anything else can I write? If e raised to power I pi is -1, e raised to power 3 pi will also be -1. If I add 2 pi, basically I'm rotating the same circle, so I'll get back to the same place, right? Theta I'm rotating by 2 pi. Theta plus 2 pi is theta itself, right? Same thing. E raised to power 5 pi will also be -i. You can put it in a calculator. Sine cos of 5 pi plus I sine of 5 pi, you will get -1. So how can I represent this here? I can represent it like this. It will be like odd multiple of pi, right? It will be odd multiple of pi. So odd multiple we represent it like this: 2k plus 1, and k is any integer where k, right? I'm taking the cube root. So only I will take values of k equals to 0, 1 and 2, 3 values of k. So it will be 3 values of k. So this will be e raised to power I pi by 3, then e raised to power I, this is 1, so 3 by 3, which is I pi, and plus e raised to power, this will be 2, so 4, 5 pi by 3. Okay, 5 pi by 3. So what are these? What are these basically? So what is e raised to power I pi by 3? It is simply, I can write this here. It is cos of pi by 3. Cos of 60 is 1 by 2 plus I root 3 by 2, and again, right, sine of pi by 3, sine of pi, it is -1 itself. So cube root of -1 is -1, because if I do cube of -1, I will get again -1. So it satisfies, right? If you just check, if you do the cube of this, you will get again -1 itself, right? You will get -1 itself. Okay, and what is 5 pi by 3? What is 5 pi by 3? 5 pi by 3, right? If you compute, basically it is you can put it in a calculator. It is 60. So it is cos of 300. Cos of 300 will be what? Cos of 300 will be something positive, right? Cos of 300 will be something positive, which is half. Okay, basically it is 60. The difference is 60.360, so it will be half. Or you can put it in a calculator, you can compute, right? If you have confusions, always put it in a calculator. Cos of 300, it should be in degrees. That is important. Then like if you tend to forget, right, you can draw the waveform also here. If you draw the waveform, every confusion will get clear. So cos is something like this, right? If you remember, cos is something like this, and after this is what, 270. So after this, what, this is reducing. So maximum value was 1, and now this is reducing, and here this will complete a cycle. So this point is what? This point is 90 plus this. So this point will be 3 plus. Okay, am I making some mistake? 19 to 4. No, am I making some mistake? That is what I'm thinking. This point will be what? 27. This is 0. This is 90. This is, okay, this is 180. Sorry, this is 270, right? This point is 270. Sorry. Now I've just started from going here, and I have added 30. So 30 will be, I've just gone 30, right? 30 will be much lower. So I will lie somewhere around here, which will be 1 by 2. If I go 60, it will be 330. I will be somewhere around here, which will be root 3 by 2. Like that, you can remember these things, right? This is for cos and that is for sine. So how can I remember? Like this, you can remember, right? And for sine, same thing will happen. For sine, this will be negative, because sine pi to pi, 2 pi, it is anyways negative. It will negative, and it will be just the opposite. If this is half, then this will be root 3 by 2. Just the opposite, right? If you have seen, if sine theta is half, then cos theta will be root 3 by 2. If and obviously you have to take care of the sine magnitude I'm talking about. And if cos theta is half, sin theta will be root 3 by 2. Magnitude you have to take care of. Okay, but is this something familiar to you? This, right? This is what? This is simply minus of omega. So this is, if you observe carefully, this is not minus of omega, this is minus of omega square. So this will be minus of omega square, and this is minus of omega. How can you say, like, can you intuitively say about this? Why is that the case, that my cube roots? Yeah, sorry for the interruption. Actually, my phone storage got over, and I was talking and like it wasn't recording anything. So like I just written it over here that if I write this minus of 1/3, right? If I just separate this out, so minus 1 whole cube is minus 1 itself, so I can separate this minus 1, and this is still here, right? I have still 3 roots. How can I write this 1 raised to power 1/3? Either it can be 1, or it can be omega, or it can be omega square. Okay, so it can be 3 of these things. That's why a minus n is also present over here. So the roots will be minus 1, minus omega, and omega square. That is how you write this, right? So now we'll go to the next topic, that is the nth root of unity. So there are few properties about nth root of unity. So what will be the nth root? Basically there will be n roots this time. Again, I will follow the same process. I replace, this time I can't factorize, so I will replace my 1 as e raised to power 2 pi k raised to power 1 by n. Okay, so this will be what? E raised to power I 2 pi by n into k. Okay, this will be it. So now until when I will go, until what value of k I will go? So k will start from 0, 1, 2, 3, and it will go until n minus 1, because it is starting from 0. Previously I had cube root, so 0, 1, 2, that's it, 3 roots. So if I have n roots, it will go until 0, 1, 2 up until n minus 1. So my roots, what will be my roots? My roots will be z equals to, first root will be e raised to power simple this, if k is 0, so first root will be 1 itself. Okay, then second root will be e raised to power 2 pi by n. Third root will be e raised to power 2 pi, this will be whole square by n, and so on, right? And the last root will be what? It will be e raised to power n minus 1 by n minus 1 into pi by n. 2 will also be there, so 2 pi into n minus 1 by n. Okay, and obviously don't forget I have I also, okay, these are not real numbers, these are I. So this will be your roots. So is there any theme that you are observing? So basically if I name this as 1, if I multiply this with e raised to power I 2 pi by n, I'm getting this. If I multiply 1 with e raised to power I 2 pi by n, I'm getting this. If I multiply again e raised to power I 2 pi by n, I'm getting this, right? So basically if I assume this as my alpha naught, okay, assume this as my alpha naught, so this will be alpha naught, this will be alpha naught whole square, and so on, and up until here this will be what? So this will be alpha raised to power n minus 1. So my roots, right, basically my roots are, basically they are in geometric progression, they are in GP. The roots are in GP, that is what exactly is written over here. If alpha, if 1, alpha 1, alpha 2 are the roots of nth roots of unity, then roots are in GP. Common ratio is alpha, which is e raised to power I 2 pi by n. That is what exactly I proved previously. And the sum of roots will be 0. Basically why? Because again, right, here coefficient of what? Just the next term, z raised to power n minus 1 is 0. Because that is the rule of formation of formation equation. Coefficient z raised to power n minus 1 equals to 0. Okay, coefficient of z raised to power n minus 1 equals to 0. So that's why sum of the roots will always be 0. Or can you prove it? I know the roots, right? I know the roots, which is 1 plus alpha, common ratio is alpha, then plus alpha square plus going up until n minus 1. You know how to like what is the formula of series or sequence, and alpha is alpha is basically what? Alpha can be anything, right? This is not alpha less than 1, so alpha can be anything. So I will write the whole formula. What is the whole formula? It is basically 1 a minus r raised to power n, which is alpha raised to power n divided by 1 minus alpha, right? 1 minus alpha. If I have, how many terms I have? Total n terms, right? 0, 1, 2, 3, total n terms. So this is n, and this is the formula simply 1 minus alpha raised to power n divided by 1 minus alpha. Now alpha cannot be equals to 1. The common ratio cannot be equals to 1. Okay, if it is equals to 1, then this will be 1 times 1 times 1. Alpha is not equals to 1, we know. So obviously this denominator will not be equals to 1, right? alpha is not equals to 1. We know this because if alpha is equals to 1, then what will happen? This will be 1 times 1 times 1. I will always get 1. All the roots are 1. No, that is not possible. So what is alpha equals to? If you remember correctly, alpha equals to this, right? Alpha equals to this. This is what? If I write this correctly, this simply equals to what e raised to power 2 pi raised to power 1 by n. So what is e raised to power I 2 pi? It is 1. So 1 raised to power 1 by n. Alpha is equals to this. So alpha equals to 1 raised to power 1 by n. So if I raise on both sides raised to power n, this will be alpha raised to power n equals to 1. So alpha raised to power n equals to 1. So the numerator is going to 0, not the denominator. So it will be simply equals to 0. So I have proven this also, right? I've given you the intuitive proof that, like, with the equations, that the coefficient of z raised to power n minus 1 is 0, or I have proven it to you that alpha raised to power n, like, as the roots are in GP, this numerator will go to 0. Okay, there are a few more properties, which is alpha raised to power n will always be equals to 1, like I have already just proved it, and alpha raised to power n by 2 will always be equals to minus 1. Why is that the case? Because what is alpha? Alpha is e raised to power 2 pi. Okay, now if it raise it to the power n by 2, like alpha is e raised to power 2 pi by n. If you raise it to the power 1 by 2, it will be e raised to power I pi. So basically this, right, this will be alpha raised to power n by 2 will be simply e raised to power I pi, and e raised to power I pi is simply minus 1. That is why. And obviously the product of roots, now this you have to take care of. What will be the product of roots? So I can derive the formula for product of roots. So let me write the roots. 1 raised to power 0, then alpha raised to power 1, then basically this is the first term is alpha raised to power 0, right? Alpha square, then alpha cube, and it is going on until alpha raised to power n minus 1. Okay, alpha raised to power n minus 1. Now if I multiply this, right, this is simply getting multiplied, right? This is simply getting multiplied. So what will the powers will get added? So this will be alpha 0 plus 1 plus 2 plus n minus 1. So this is the sum of first n minus 1 terms. Natural sum of first n minus 1 terms. We know the summation formula of first n terms. What is the summation formula of first n terms? It is simply, if I have 1 plus 2 plus 3 dot n, it is n into n plus 1 divided by 2. Instead of n, right, I have n minus 1. So I will also replace here n with n minus 1. So this will be alpha raised to power 1 plus 2 plus 3 going to n minus 1. This will be simply n minus 1 into n divided by 2. Okay, now what fact is interesting over here is this, right? This is what alpha raised to power n by 2 is minus 1. So what I can do? I can write this as minus 1 raised to power n minus 1. Okay, and if now my n is even, if my n is even, this whole thing will become odd. So this will give me minus 1 itself. So n equals to 2, n equals to 4, whole thing will be odd. It will be minus 1 raised to power 3 or minus 1 raised to power 1. I will always get minus 1. If n is odd, that means what is it? It is basically 3 or 5. So this whole n minus 1 will be even. So if it is even, so obviously minus 1 raised to power square, minus 1 raised to power 2, minus 1 raised to power 4 will be always 1. So if you can remember, well and good. If you can't, you can derive. It will take you 15 seconds to derive, right? So you have to understand what is my capability. My capability is memory, or my capability is derivation. So all these things you have to understand. Okay, it will take 30 seconds for you to derive if you solve it quickly. So let's solve this question, right? Like this is about the nth root of unity. So whenever these type of questions come up, right, you just separate the 1 by 4 term, the denominator term of the power, right? What do you do? First of all, what you can do? You can write, like, you can separate out 1, right? You can separate out 1. Always do this. So 16 raised to power 3 by 4. I can write this as 16 raised to power 3 by 4. So I know what will be one of the roots that I know, right? It is 16 raised to power 3 by 4. And this is 1 raised to power 3 by 4. I know what is this. What is this? I know the simplest root, right? So what is the simplest root? If I do the quartic root of this, what will be it? It will be 2, right? 2 raised to power 3 will be 8. So this will be 3. This will be 8 times 1 raised to power 3 by 2. Now what I'll do, I will do this, I will first cube this, okay, cube this, then I will do 1 by 4. So this will be 8 raised to power 1 by 4, because 1 cube is 1 itself. And the simple term, right, you know, right? I know the simplest term, that is 8. Like the answer to this will be 8. One of the solutions will be 8. Confirm. But what will be the other solutions? I will find out from here. Now I can replace my 1 with e raised to power 2 pi. E raised to power I 2 pi k divided by 4. So now you can write k equals to 0, k equals to 1, k equals to 2, k equals to 3. So for k equals to 0, the roots will be 8 only. For k equals to 1, the roots will be e raised to power I pi by 2. Obviously there is 8 also connected with it. And this will be 8 e raised to power this will be e raised to power I pi, okay, and this will be 8 e raised to power, this is 6 pi, this will be 8 e raised to power 3 pi by 2, okay. So how are they differing? Every pi by 2, right? And that makes sense, right? Because if I divide 2 pi by 4, it will be pi by 2. So they are differing by pi by 2. And this is what I have like told you, right? Remember this, right? What is this? This is simply 8i. So this will be 8. This will be 8i. So if what is the common difference? Common difference is I. So next will be multiplied I with it. So it will be 8i square, which is minus 8. And again multiply I, which will be minus 8i. Okay. So these will be my roots. So I know they are in GP, so I can simply multiply I or whatever, right? You can directly compute this. You can directly also compute this. Doesn't matter. You will get the same answer. So what will be the answer? This is MSQ. So answer will be A, B, C, D. So obviously 8 was one of the roots that we already knew. But I have 3 other roots also, because here, right, this is raised to power 1 by 4. So I will get 4 roots overall. So these are the 4 roots, right? These are the 4 roots. So all of them will be my answer, okay? So now we'll start with the locus in the complex plane. So basically, what do we mean by locus in a complex plane? So basically, locus means path, right? We have already, I think, drawn few locus of functions, right? During starting of functions lectures, drawn few graphs. So exactly that is what a similar thing we will do here. Basically, we will plot the locus in complex plane. So what is the locus of a point? Point is basically constants, right? So if I have a constant a plus like 3 plus 4j, if I have a number like where my a is 3 and b is not j, sorry, b is 4. So if I write like here, what will be this? This will be 3 plus i4, right? 3 plus i4, which will be somewhere around here. Okay. So that is my point in the complex z plane in the rectangular format. Okay. Now if I want to plot it in the like if I want to define in the polar format, what will it be? So simply what will it be is I will again draw a circle, and this time, right, I am trying to define, let's say minus 3 plus 4 I plus 4, right? Basically minus 3 i4. So minus 3 will be somewhere around here, and i4 will be somewhere around here at the top. So it will be somewhere around here. So in point you are seeing I'm here, but if I want to find in terms of angle what I have to rotate, it will be what? Tan inverse mod of y upon mod of x, which is tan inverse 4 upon 3, which is 53.13, and 180 minus that. So 180 minus that will be this here, right? Okay. So this much amount of angle that I move, and what is the magnitude of my pointer? The magnitude of my pointer is 5. 3 square plus 4 square root, it is 5. So the magnitude of the pointer will be this. I will draw a pointer of 5 distance from the origin, and then I will rotate from the positive x-axis to 180 minus 53.13 degrees. Similarly, same case over here itself, the angle will be here directly 53.13 degrees. Okay. So the magnitude will be again 5, and I will be 53.13 degrees in the anti-clockwise direction. And in rectangular format, I hope you understood how we represent a point, right? C and D are constant. So now let's understand the locus of a line. If I want to plot a locus of a line in the complex plane, how will I plot it? So I will vary one of the parameters. So here, right, none of the parameters are varying. So this is 0 dimensional. Okay, 0D. Point is 0D, right? It is nothing. It's just a point. Now, if I vary one of the parameters, it becomes one dimensional. So one dimensional means line. 1D means simple line, right? So that is what 1D is. So if I vary my x from negative infinity to positive infinity, and my b is constant, okay? So the distance from the x-axis is constant, which is b, and my x is like my x is varying, so it will be like this. So you can understand from the pointer also. So my x is always varying, but my y distance is constant, right? So r is also varying, theta is also varying. So that is another way to understand. So that we won't go. Okay, that we won't go in the polar format. We will just understand in the rectangular format itself. So here my x is always varying, but my distance from the x axis is constant. Okay, but x can go from minus infinity to plus infinity. So we will get a line which will be parallel to x axis. Okay, now, or you can say the real axis. If my y is now varying and my x is constant, so if x is constant, y is varying, so we'll get a line which will be parallel to y axis, and the distance from the y axis will always be constant, which is a. Okay, which is a. So distance from the y axis will always be constant, which is a. Okay, so this is how you get a 1D line. Nothing much to explain here, right? So now if I want to get a 2D surface, right? 2D, this was just a line, 1D line. Okay, now if I want to get a 2D region, so that will be called a surface. So I have to vary two things at once. So now I'm varying x also and y also. So x is varying from minus a to b. Okay, so like a and b both are positive, or a and b can be anything, right? Okay, but x is varying from minus a to b. So this will be, okay, just hold on. This I should write as minus a, right? A and b, a, b, c are positive. So this will be minus a to b, and this will be minus c. I'll just mention here that a, b, c will be positive. A, B, C and D will be positive, which is greater than 0. Okay, so A, B, C will be positive, which will be greater than 0. Okay, so that is the case. What I'm getting a region, right? So if I'm varying my x from here to here, and my y is also varying from minus c to d, so it can be combination of any of these two. So obviously I'm getting a what? I'm getting a 2D region, which is also known as a surface, right? 2D region, which is a surface. Okay, or you can say like a plane also. So if I'm varying two things, now let's understand, like 2D you've understood. Obviously 3D we can't, because only I have two axes. One is a real axis, one is an imaginary axis. So 2D we are done with 2D. Okay, so now let's understand about the circle. So obviously we use the polar format to represent circle itself, right? Anything else we will use the rectangular format only. So for circle it is very easier for us to do our mathematical operations with polar format. Okay, so obviously you know all this, right? R, I, theta. So basically what is R? R is the distance from the origin, and theta is what? The angle. So here, right, my theta will vary from what? Minus pi to plus pi. So minus pi means from here to here. So obviously it completes a complete circle, 2 pi. The distance between them is 2 pi. So it will complete a complete circle, right? And R is what? R is magnitude of A. R is magnitude of A. So R is magnitude of A. So it will be simply the distance from the origin, which will be constant. Here in our case, R is constant. R is constant, but the theta is varying. So what I will get, as R is constant, so the radius is constant, but theta is varying. So I will get a what? Circle. I will get a circle in the anti-clockwise direction. Okay, anti-clockwise direction. Here, as it is going from minus pi to plus pi. If it would have gone from plus pi to minus pi, I would have got a circle in the clockwise direction. Exactly, that is what written over here. Circle with center 0, 0 and radius e. Okay, so basically I will write that my R is constant and theta is variable. So I will get a circle of constant radius. As my R is constant, the distance from the origin will always be constant, and I will get a closed curve. Obviously this will also cover a surface also. Okay, I will get a closed curve. So this is about it. Anti-clockwise, clockwise, 0 to pi, 0 to pi. So yeah, anything else? Like here I can observe that R is mod of A. You would write mod of A because A can be positive as well as negative, but it will always be the magnitude of it, right? So yeah, this is how you represent. And like what will be your x square, x and y, if you want to convert, right? You already know all this. X square plus y square will be equals to A. Hence x square plus y square will be A square simply. Okay, will be C square, A square, which is what? Which is equation of a circle. right? As the distance is constant, obviously I am getting an equation of a circle of radius a and center 0, 0. So right from here itself, right? From here itself, as the distance r is what, x square plus y square, which is equals to a, which is simply positive, right? So yeah, that is how you find it out. And clockwise and anti-clockwise you have to understand through the notation given, right? Whether it is going from pi to minus pi or plus minus pi to plus pi. Okay. Now like let's do an example, right? Plot the locus of a complex number z equals to 5 e raised to power I theta, where my argument of z, that is angle theta, is going from minus pi to 0. It is going from minus pi to 0. Okay. So how will it go? So here, first of all, the magnitude is constant. So obviously this is the format of a circle of radius 5. Okay. With center 0, 0. And I'm going from minus pi to 0. So it will be somewhat like this, minus pi to 0. Okay. And this distance, right? This distance will be 5. This is minus pi. Okay. How shall I explain this minus pi? So how I will explain is, if I take a pointer over here, this pointer will be simply minus pi. Okay. And I'm going from minus pi to plus. So I don't need to take any pointers. So I'll just try to write this. Okay, so I'm going from minus pi to plus 5, and the distance, right? The distance is what? From the origin. It is always constant, which is 5 units. Okay, which is always 5 units. So I'm going in the what? Anti-clockwise direction. Right? Yeah, there is one minor mistake over here. I should actually mention the direction, because else like students may get confused. Like they can also go from 0 to minus pi as well. But I know, like, if nothing is mentioned, right, by default you will start from this. Okay, just hold on. This will be your lower limit. Okay, and this will be your upper limit. You start from this and go until this, right? And as argument is always negative, you will go from this negative to positive only. You can't get here, right? Because here argument is positive, which is not possible. So generally they should provide the direction. Most cases they will provide 99% of the cases. 1% case, if they don't provide, you will follow this convention. Okay, but most cases they will provide the polarity. So I forgot to like write this in the anti-clockwise direction. Okay, so in the anti-clockwise direction, so this is 5 and you go like here, right, in the anti-clockwise direction. So this is the basically what? This is simply the locus of 5 raised to power e raised to power I theta, 5 into e raised to power I theta. Okay, so now let's understand the locus of a disk. This time, right, that was a 1D surface, that was a closed curve, right? This was a closed curve. Okay, we got a closed curve over here. Now we can get a 2D plot. How can I get a 2D plot? Basically what you can do, you can vary both r and theta. So if I vary both r and theta, what will happen? Let's say my r varies from 0 to a, right? So obviously I get a disk with center 0, 0 and radius a, because my pointer distance will also keep on varying and it will also keep on rotating. So obviously I will cover everything, right? I will cover everything. I will cover this whole disk. So I will cover this whole surface. I will cover this whole surface. Okay, so this is the case. You just simply get a disk if my radius also varies. So next is equation of circle. So what we have seen like this, right? Here what is happening is that if I replace my mod, what is my mod of z? Mod of z is x under root x square plus y square, which is between, like, r is what? Between 0 to a. So it should always be less than a. Now if I square this, x square plus y square should always be less than a square, which we have done this multiple times in what? Integral calculus. I have already plotted everything, right? So there, like, you can understand, like, it will cover all the circles whose radius is less than a. Okay, so that's why this is disk. Now can I write the equation of a general circle whose center is not 0, 0, whose center is lying somewhere else? How can I write the equation of a general circle? So what you can do is that, what is the magnitude of CP? Like CP, let's say CP is my radius, which is r. Okay, and my circle is not lying at 0, 0, it is lying at some center z0, okay, and the center z0 I can represent it like this: z0 equals to a plus ib, some constant value a plus ib. Now z0 is okay, z0 is already written over here. If z0 is this, then what I can write is this, right? The distance, if I take a point over here, okay, distance from here, z minus z0. So center is here, okay, center has been shifted here. If like z is this vector, let's say on this axis, and z0 is this vector, so if I subtract this, what will I get? So that is what I'm trying to think. So z minus z0 equals to r. So magnitude is z minus z0 equals to, okay, yeah. So this, right, the distance between these 2 points, this is my z, right? Like here, like this is z, but this is like z is, this is the variable point, right? This is a variable point which is z. This is z, right? So z minus z0, and if I take the magnitude of this, the distance should be r. Okay, this is my z, and if I subtract this point at z0, because previously I was subtracting 0 because I was computing my distance from origin, but now I'm computing my distance from z0, so I will obviously subtract z0. So z minus z0, and if I take the magnitude of it, I will get simply r. Okay, so can I further write this? Yes, I can. So z minus a plus ib, with z0 is a plus ib, magnitude is r. What is that? Z is x plus ib, right? X plus iy. So it is x minus a whole square, if I compute the magnitude formula, plus y minus b whole square equals to r square. Equals to r square, okay? So x minus a whole square, y minus b whole square equals to r square. So like, what is this equation of? You know this equation, right? This is basically a circle, equation of circle with radius r and center a comma b. Basically what we have assumed, right, whatever we have assumed is correct, because after solving this equation I'm getting this equation, so which is satisfying, right? My z0, the center is of the circle is a comma b, and the radius is obviously r. So the distance from this 2 should be constant, which is r, which I have written over here, and by that we deduce the formula. So whenever you have been given some format like this, right, whenever you have been given some format like this, just remember this should be negative. If this is negative, then the center will be plus ab, okay? If this is not negative, the center will be just the opposite sign, whatever there is. So if it is plus a, the center will be at minus a. If this is plus b, center will be at minus b. If this is minus b, center will be at plus b. I mean the y coordinate and the x coordinate respectively, right? So you have to understand that. So yeah, I just forgot to write the question numbers. So okay, this question number also I forgot to write. Okay, I'll write those later on. So now let's solve this basically. So we have to plot the complex number, locus of the complex number, which is mod of z minus 1 equals 1. Why is this important? This will be important in integral calculus, that's why. And anyways, you should know the locus, right? So basically, how can you plot? Can you identify the center and the radius from here? This is z minus z0, and my z0 is what? 1 in this case. So my a is 1 and b is 0. So obviously center circle, it is a circle with radius. What radius is current given over here, which is 1. So circle with radius 1 and center 1, 0. So center 1, 0. So basically center will lie somewhere around here, and radius is 1. So obviously this distance will be 1 and this distance will also be 1. So obviously we can plot the loci simply just like this. So it becomes so easy, right, to plot this. Else if you don't know the format, you wouldn't be able to plot this. Plotting this will be very difficult for you. So this is the center 0, 1, 0, and this is the radius, which is 1. Okay, so yeah, or what you can do, you can simply solve this equation. If you solve this equation, okay, solve this equation, it will be what? X minus 1 whole square plus y square equals to 1. So from here also you can understand that I will get a circle with radius 1. Now and also center 1, 0. can you find the intersection with the x-axis? So from here you can easily find out what is the intersection with the x-axis. Like this circle is pretty easy, but few circles will be difficult. How to find on those terms? So the intersection with x-axis, intersection, because those points, right? Like you might be given options, and you have to eliminate the options with the intersections with the x-axis or y-axis. So you should understand how to find these things. Intersection with x-axis. It will be whenever I am talking about x-axis, my y will be 0. So I will put my y 0. If I put my y 0, x minus 1 whole square equals to 1. So I can write x minus 1. I can take the under root, which will be plus minus 1, right? Okay. It can, because if I take the square on both sides, again I will get back this equation. So obviously I will have a plus minus 1 over here. So my x will be equals to what? Either 0, or if it is plus 1, it will be plus 2. So exactly this is also like telling the correct thing only, because here this is 2 comma 0 and this is 0 comma 0. Okay, and where is it touching in the y-axis? I'll put x equals to 0, and when I put x equals to 0, this will be simply y square equals to 0, which will be y equals to 0 still, because minus 0 plus 0 is same thing only. So I will write here intersection with y-axis. Okay. So it is x so intersection with y-axis. So obviously my x will be equals to 0. So if it is 0, so this will be 0 minus 1 whole square plus y square, obviously, and this is 1 square. It will get cancelled, so y square will be 0 and y will be simply equals to 0 itself. Okay, 0 comma 0 is a intersection point, 0 comma 0, and here it will be 0 comma 0 and 0 comma 2. Okay, these are my intersection points. So yeah, that's basically it for this question. Let's go to the next question. So here, right, they are asking us to like this has given the equation, they are asking us find the greatest and least value of mod of z. So pretty interesting question. So how can we find out the greatest and least value of mod of z? So either you can go with the mathematical thing, or you can go with the graphical thing. So first I will try to do it with the help of graphical. So okay, so like what is this equation? So if I am able to read this equation, this is z minus z naught. So can you tell me what is this? This is circle with radius, what radius 13 and center 5 comma 12. So circle with radius 13 and center 5 comma 12. Okay, so I will be lying somewhere around here. Okay, somewhere around here, and my center is here 5 comma 12. Okay, and this is my x-axis and this is my y. Okay, so what are they asking? They are asking me the greatest like the least and the greater value of magnitude of z. What does magnitude of z represent geometrically? It represents the distance from the origin. And what z is? What z is? Any point lying on this circle. So what is the highest distance and the lowest distance, okay, from the origin? Can you see the hint? So if I draw a straight line and connecting the center, okay, this will be the highest distance, right, just at the end, and this will be the shortest distance, because after this what is happening? The distance is increasing, right, increasing, and then right again what is happening here? It is becoming the maximum. So obviously if I just simply draw a line connecting the center and the circle, so geometrically, like, don't go exactly here because my drawing may be a bit off. So this is, let's say, B, and this is O, right? Let's say this is C. So the z minimum, right, magnitude of z minimum will be what? This is O, let's say, will be OA and Z maximum will be OB. Okay, so Z minimum is OA, Z maximum is OB. So you can compute, right? Do we know the OC distance? Do we know it? Yes, right? Because this, what is the C point? This C point is 5, 12. Sorry, this is not radius 13. Sorry. This will be radius 1, right? This will be radius 1. I'm sorry. Because the radius is defined by this, not by this. Sorry, I was wrong. So this will be 5, 12. Okay. So this is 5, 12. This point is 5, 12. So this is in the x direction. This is 5 units. If I just drop down, and in the y direction, this is 12 units, right? Okay. Y direction is in the 12 units. So like we can compute this OC distance, and this OA will be what? OA will be simply OC minus AC. And what is AC? AC is basically the radius, right? And what is this radius? Radius is what? 1 unit only. Radius is 1 unit only. So OA will be, I can write OA as OC minus 1, right? And what is OC? OC is simply this 5 square plus 12 square under root, which is 13. So OC will be 13 minus 1, which will be 12. And what will the highest distance? The highest, right? This is OC plus CB will be equals to OB. So I can write OC plus what? What is CB? CB is 1 itself, right? Again, this is the radius of the circle. CB, OC plus 1 equals to what? Equals to OC is what? OC is 13. So 13 plus 1 equals to 14 itself. So 12 and 14 will be my answer to this question. So basically that's it for this lecture. And like I know it took a bit of time because we had to cover a lot of things in basics, right? So from the next lecture we'll start basically our main topic, that is complex variables, and we'll start with differentiability and differentiation of complex variables. Thank you for watching, and I will see you in the next lecture.